Good morning, ladies and gentlemen. Please welcome to the stage the head of developer advocacy for Google, Timothy Jordan.
Hi, everybody. Welcome to the Ubiquity Dev Summit, Day 1. Before we get started, I wanted to tell you a little bit about our code of conduct. We want everybody here to have the best experience possible, and we value an inclusive community. No matter your background or experience, you're welcome at the summit. And we encourage you, therefore, to be excellent to each other and know that we have a zero-tolerance policy for any harassment of any kind. Our code of conduct is posted around the venue and on the website. All right, and with that, I'd like to get the conversation started with a colleague who couldn't be here in person today.
Hi, it's Vince Cerf. I'm Google's chief internet evangelist, and today I want to rant about the Internet of Things. You're going to hear a lot about this, and from me, you're going to hear several things. Specifically, you're going to hear that things need to interwork. Nobody wants a million different hubs that they have to configure for each different product from each different manufacturer. We're going to have some standards, international standards, that will allow people to manage and configure and control access to these devices, which leads me to another point which has to do with security. It's important that these devices be updatable so that bugs and mistakes that might leave them vulnerable can be corrected. But that also means that when the device ingests a new load of software, it has to be able to make sure that that particular load is legitimate. So we need to digitally sign things, we need strong authentication so that a device that's getting a new software load knows where it came from and can assume that it's a safe load to install. By the same token, I'm very concerned about privacy, and the reason for this should be obvious. There's a lot of information that even sensors could collect, like temperature sensors where you're sampling every 5 minutes. After a while, let's say after several months, you might be able to figure out how many people live in a home, which rooms do they occupy, what is their typical schedule for coming and going. But on the other side of that, suppose the house is on fire and the fire department comes and wants to know where is everybody. Some of them may be unconscious, so if there's a way to tell who's in which room, or at least that someone is in a room, that might turn out to be a life-saving piece of information. So we really need to make sure that as we design these devices that are part of this Internet of Things, we pay close attention to interoperability, strong authentication, privacy and security and safety, so that the users will have confidence that the devices they buy from us and others will in fact be things that they can rely upon. That's a big burden on everybody's shoulders, but it's a responsibility and an obligation that we must undertake. Otherwise, no one will be interested in buying and using the products that we make and want to sell. So I hope you have a great conference. I'm sorry I can't be there with you, but I hope I'll see you on the net.
Thank you to Vince Cerf for getting our conversation started. Now, I'm going to continue it with a little bit more detail in that context. Let's start with this question. Have any of you thought about what the living room of the future will look like? Lots of yeses. Give me some ideas.
I'll be a couch potato.
I'll be the couch potato. What will the living room of the future look like? Any other? Yes. Apps.
It'll be automated.
Automated.
Basically, turn on your favorite television shows if you're in the mood for TV.
It'll be automated. It'll know your favorites and your preferences. These are all great ideas. And it's interesting, actually, when I usually ask this question, people focus on the technology. And, I think that's key for us to do. But here's what our colleagues at Nest came up with when their CEO, Tony Fadell, asked them the same thing. I really love this picture, and I'll tell you why. It's a little messy, it's a little playful, but the most profound thing is what it isn't. Right? There aren't screens and keyboards everywhere. You can hardly see the technology at all. Instead, it fades into the background, supporting the users, this family, in many subtle and effective ways. So when you think about ubiquitous computing or the Internet of Things, don't think about technology getting in the way everywhere or being overwhelming. Think of it blending in and helping everywhere it makes sense and is useful for your users. With that in mind, here's 3 pillars for us to start our journey together. And it's been my experience that the most successful companies that I've observed and met in this space, well, these are the 3 things that they're most passionate about. The first of which is interoperability. This is systems, protocols, and IoT schemas that are based on open standards and enable interoperability as well as modularity. The second is security and privacy. Data control, access control, and identity management are fundamental, regardless of who made the product or how users access it. And the last one is human interface. And this is all about new paradigms for HCI that rely more on natural metaphors. Let's dive into a little more detail on each of these 3 pillars. First, interoperability. Now, historically, engineering teams have built their own solutions to solve their own problems, each creating their own proprietary protocols and further isolating their devices from the rest of the world. However, if you have common IoT protocols, not only does this mean less work for the device manufacturers and app developers who no longer have to keep solving the same problems over and over again, it also means that these devices can talk to each other, and app developers can integrate multiple devices into their feature set. Next is security and privacy. And this is all about having everything be secure and giving users the right insight and options to control their experience as appropriate. In a little more detail, what that means is hardware and software makers should provide security and privacy by default, building in essential platform features like over-the-air updates. We need to build user trust at every turn so that they're confident of the security of their data. And we should provide users with the controls to manage their digital identity and data per sensor, per account, per product, and per home. And finally, we need to ask the user before sharing any data with other devices or services, and of course, this helps build user trust. The last pillar is human interface. And this is all about new paradigms for user interface and interaction design, or you can think of it as a reliance on more very old paradigms of natural interface. And a common pitfall here is to build an app walled garden. Now, apps are important, and we'll have them for some time yet, but think about building a platform, right? And part of that is through your app, and part of that is that users can access their devices in a variety of other ways, including physical interfaces and other apps and services. Also, here's some design principles for really great user experience on IoT. First, the user experience should be so simple that it feels effortless. In the long run, users always prefer simplicity and reliability over features. And whatever user problem you solve, make sure to focus on that and never let anything get in the way of that effort. A great example of this is messaging, right? And you'll see this on a variety of platforms. I, of course, love the experience on Android Wear. In particular, I love just being able to see the message on my watch and be able to respond to it with voice. It's so simple, it just makes sense. The next one is contextual. Now, contextual is all about being relevant, right? You want to take into the account the time, location, and activity the user's involved in so you can provide them with the most useful experience wherever and whenever it is. A great example of this is you can imagine a shopping list where the user walks into the store and the list just comes up for them, right? And before they leave the store, it reminds them of anything that they might have missed. In this case, you're providing information and experience for the user before they asked for it. And finally, it should be immediate. The experience should be so fast that it feels immediate. Being contextual can help with this, but it's also about micro interactions. And remember, you're not trying to distract or occupy the user. You just want to present the right information right away so they can get what they need and get on with their life. A great example of this is voice commands on Android TV. I can just tell Android TV what show I want to watch, and it shows me that in my library. Or autoplay and queuing with Google Cast. So the next episode just comes on right away as I'm watching through a series. All right, here's the last one, extensible. Now, I've mentioned this a few times today in a bunch of different ways because it's really important. You want to build your app so that the experience is extensible. That means the user can get to it wherever they'd like. And you want to build that into your core app and overall experience so that the user really has it at hand wherever it makes sense for them. A great example of this is music. Can you think of a time in your life where you wouldn't want access to your music? Right? Whether that's like on your phone, going for a run, in your living room, or in your car, you should be able to, as a user, have that music experience in any of those contexts in the way that it makes sense in that context. So these are our 4 principles for UX design, human interface, that we can keep in mind, keep in our pocket as we build in this new space. And with some more detail about that, building in this new space, I'd like to welcome to the stage Gayatri Rajan, Vice President of Product at Brillo and Weave.
Thank you, Timothy. Hello, everyone. IoT is here, and it's pervasive. These things will soon outnumber phones, tablets, and laptops. Or to put it another way, in just 5 years, there will be 26 of these smart devices for every human on the planet. So that's the good news. But there are significant issues today that could hurt adoption of IoT. A survey conducted on IoT executives highlighted that the top barrier, the thing that they're most concerned about for IoT adoption, is interoperability. There are simply too many fragmented protocols and siloed ecosystems today. It's also important to note that security concerns are a fast follow. And if you ask consumers, they'll say they still don't see the promised value. But where there are problems, we and you see opportunity. The opportunity that lies ahead for IoT is to rethink those user experiences in fundamental ways. First, reimagine the products themselves. Look at ways we can make the devices themselves smarter with the power of the net. And second, choreograph these experiences across ensembles of objects and services so that in concert we can create true user benefit. But in order, oh, I forgot to do that. So let's, as an example, let's take something as utilitarian as a washing machine. If we were to add connectivity and the power of the net, you could reimagine a smarter version that is activated by voice commands, that understands the user and its context, that knows when it's not operating efficiently. Now let's amplify this further by orchestrating experiences with other services and devices. The washing machine now learns about the activity in the household and its energy use, and can then determine when to start the wash cycle, when it's optimal for household convenience and energy savings. It knows when to order detergent when it's close to being exhausted, and it can do that automatically. The possibilities here are endless. I think this audience will have ideas that take this a whole lot further. But to get to this vision, we believe openness is an imperative. You've heard this before, but we think this bears repeating. These devices must be able to communicate with each other across brands. And the data that they generate must be comprehensible, so developers can scalably build intelligent services on top. Which brings me to security and user privacy. In this interoperable ecosystem with all these devices from different brands connecting to each other, security becomes increasingly critical and must be built into the devices themselves and the device interactions. It should be really easy for users to control who and what can access a device and exactly what they can do with it. User and device data must be protected from unauthorized access, be the data stored on the network, on the cloud, or on the device itself. Really, really important that it's protected. And finally, the device itself must be made resistant to attacks. And in the event of a compromise, it should be really easy to fix it and bring it back to a trusted state. Which brings me to Brillo and Weave. Brillo and Weave is Google's approach to building for IoT. We've built security features into the Brillo and Weave platforms, so you can use it to build secure devices and device interactions. And we've deliberately made Weave an open protocol, so it's easy to build apps and services to securely set up your device, control them, and choreograph those experiences across different devices. But ultimately, our vision for Brillo and Weave, and this is really important, is to enable our partners and the larger developer community to build those great devices and experiences that users will love. We provide the foundational elements so you can create the magic. Just to give you a little bit more of an overview of what Brillo and Weave are, for those of you new to Brillo, in a nutshell, Brillo brings the simplicity and speed of software development to hardware for IoT. What we give with Brillo is an embedded, secure OS, core services, and a developer toolkit, so you can build your IoT device. And because Brillo is based on the lower levels of Android, it's supported across a range of hardware. So in addition to helping you build these devices, with Brillo, you have access to tools to help you monitor and manage your devices over its lifetime. Really, really important in this new world of connected devices. We can't just ship and forget. In particular, we provide a really easy way for you to update your device over the air. Those of you who've been building your own hardware know that this is hard to do reliably and at scale. And we believe updates are the only way you can ensure that the device stays secure over its lifetime and can recover from attacks. So that's Brillo in a nutshell. Weave is a communication platform for IoT devices. It provides a seamless and secure way for users to provision their devices onto the network, something a lot of users struggle with because today it's pretty inconsistent, device to device, and controlled, low-latency access to devices both locally as well as remotely. Weave is built into Brillo, but you can also use the Weave libraries on an existing device operating system that's based on Linux. On the client side, Weave APIs and the SDK are available on Android, iOS, and the web, so you can build apps for all these platforms. And because interop is such a critical element for IoT, what we've done is, for Weave, we've created these device schemas for major device categories. In this case, you see an example for a camera and for a lock. This makes it easy to build applications that can interact with Weave-compatible devices regardless of brand, and easy to choreograph those interactions across device types as well. So that's the basics of Brillo and Weave. You'll hear a lot more details in upcoming talks today and tomorrow. Over time, we'll be adding a lot more in terms of services to Brillo to make it easier for you to build smarts into your device. We'll be adding some really cool stuff, for example, voice actions, now like contextual triggers, so you can build some of those experiences into your Weave-compatible app. So look forward to hearing more from us. Essentially, with Brillo and Weave, as I said, we're laying the groundwork so device makers and developers and you in the audience can build the IoT devices and experiences of the future. This is a problem that we share, and we believe that there's a great opportunity to solve it together. Now, just to give you a quick sense of the possibilities, I thought I'd show you a demo of a Weave-enabled device. That's a dog feeder there, and a Weave-compatible app. So for context, Wayne's a member of our developer team, and he's an owner of 2 very energetic and hungry dogs. He'd bought this dog feeder a few years ago with the intention of getting it set up and connected to the internet, and the technology was too hard at that time, and he'd given up. So it was sitting in his garage, gathering dust. He brought it in for this demo and got it Weave-enabled in under a day. So let me welcome Wayne, and we have a surprise guest, Monty, on stage. So I'm going to show you how easy it is for Wayne now to feed Monty when he's, when he's at work. Can we switch to the phone, please? So that's his app, his Weave-enabled app. And all he has to do is click on this button and feed Monty. Well, it's easier to do the technology than get adoption, isn't it? So that was a really simple demo. To give you a flavor of what you can do, I encourage all of you to use this opportunity over the course of the next 2 days to learn more about Brillo and Weave, work on the code labs, ask questions at office hours. You'll have access to Brillo and Weave very soon later today. So this will get you an opportunity to get your hands dirty. We're really excited to see what you can build with Brillo and Weave. Thank you. Timothy?
Thank you, Gayatri.
Thanks.
And Wayne and Monty. Next, I'm very excited to welcome to the stage Rajat Manga, technical lead for TensorFlow. You can clap. That's okay.
Thank you, Timothy. Thanks. Hello, everyone. So I'm Rajat. I'm on the Google Brain team, and I work on TensorFlow. I'm the lead for TensorFlow. Gayatri, talked about a lot of devices that are going to be there in our future. She mentioned like 26 smart devices for every human on the planet. Well, I'm here to help make them smart. Help you make them smart, really. So let's talk a little bit about machine learning. Why is it so important, right? Why do we care about it? Why is it such a big thing today? So let's start by just talking a little bit about what machine learning really is and what it can do for you. One way to think about it is, if you want to solve tasks that you can't really just program, as a developer, right? That's what you want to do, to program everything and be done with. This is something that can really do that for you. So for example, the examples I have here is, you have a bunch of images, and they're labeled. If you wanted to program something that could take those images or take a new image and say it's a dog or a cat or whatever, that's going to be really, really, really hard. But you can train computers using what's called machine learning to really do that, where you have data sets which are nicely labeled images. You feed them to a computer with the right algorithms, of course, and then eventually out pops a model that you can use to classify a new image that it's never seen before. And it's used in a variety of places to do that. So now let's talk a little bit about what are the different things that you can really use machine learning for. What is it being used for today? So one of the things, just going back to the example I was doing, is image recognition, right? You can, in this case, give a picture of a lion, and it can say it's a lion with a very high confidence, and it does really, really well here. In fact, on a data set called ImageNet, which is very popular in the research community, which has about 1 million images and 1,000 different classes, the human accuracy is supposed to be something like 95% or so. And these models are now able to surpass human accuracy on that particular data set. It's not that general. I mean, it can't really see as well as you do for every little thing. But at least in these kind of images, it can do better. So it's getting really, really good. Another one is voice. A lot of you have probably already tried talking to your phone, doing searches, asking Google what's going on. In this case, somebody's asking, OK, I want to see Seattle restaurants. And it uses machine learning to really take your voice command, the audio that you have, and convert it to a query, which is then fed to the regular Google search engine and give you the great results that we are good for. Another is search. The web now has something like 60 trillion pages. The last I checked, it's probably a few more trillion by now. Finding the relevant documents from so many different pages is a hard task, right? Google's done it really, really well. One of the things that helps us there is machine learning again. Given a particular query that you make, sorting and sifting through those trillions of pages, and then coming up with 10 answers that we can show on that page, because that's all you're going to see, and maybe go a few more pages, is really a hard task. And machine learning is a great way to help solve that. Another one is translation. So if you ever tried Google Translate, where you just type a query, or you just type something in, say, English, it can translate it to French, or the other way around. And in fact, it supports 90 different languages today. I don't think we could do that with even 1 million people sitting behind and sort of translating those things for you. So again, one of those things that machine learning has made a Huge difference. Another newer one is, and this one's more researchy so far, is taking an image and actually trying to describe that. And in this particular case, as you see, there's it's able to describe a close-up of a small child just as a human word, right? And it's getting really better in things like this. Think of the kind of impact something like this can have. If a visually impaired person who can't really see can be described everything that's going on around them, it'll just be a game changer for them. It'll be a life changer for them. So these are some of the things that machine learning can do for you. Now let's go a little bit deeper into one specific branch of machine learning called deep learning. And the reason I go through this is all the things that I just talked about, they are actually, deep learning was applied, and deep learning was the one that got all those great results for us. This is a very old technology in the sense that the core ideas come from the 40s. It was called neural networks or artificial neural networks back then. Over time, it's evolved both algorithmically and with the additional data being available and the computational power that's available to us. And it's continued to improve. Especially over the last 5 years, it's starting to show great results, like in some of the fields you saw, and I'll show you some more later on. The basic idea here is you have some input of all kinds of things. It could be images, speech, text, all kinds of things. You build these networks that extract features out of them and are able to make some sense, and are finally able to make some predictions of whatever you're interested in, whatever you can train it for. And they're pretty widely applicable. The same kind of algorithms are applicable across a variety of different areas. It's very loosely inspired by neuroscience. Some people might say that's how the brain works, and we're trying to replicate the brain. Not quite true. I wish it were, but not quite there yet. It is definitely inspired from there, though. This slide is just to give you an idea of how important it is for us at Google. We started this group back in 2011, and it's been growing rapidly since then. It's, as this shows, this is just a rough idea of how many different teams are using it, but the number of different directories that have models built off of this technology, and there are all kinds of applications and areas that are using this technology. So that's great. So, I've now given you a background of what machine learning is. Now let me dive into something called TensorFlow. It's a machine learning library that we just open sourced recently, and I'm going to talk a little bit more about that. So let's start with what is TensorFlow. It's a library that lets you do all the things that I was talking about. It's a library that that allows you to build these machine learning models and deploy them in production. And it powers hundreds of different products at Google today. I listed some of the names of areas that use that, but there are many, many more. It is something for researchers to try out new things, to build new things, but also for developers to deploy these models into production or applications or products, whatever you have. And it's really important to be able to do that. With all of this put together, what it allows us to do is really to build the next generation of intelligent applications, right? We have a lot of different applications. We have a lot of products. How do we make them intelligent? How do we make them smart? That's our goal. We want to help enable that. And we did open source it, so it's available to you now. We open sourced it a couple of months ago. It's on GitHub, and I'll give you some pointers at the end of the talk. But it's there for you to try out, to do a lot of things with. So let's talk a little bit about, what does it give, what does it have, what is TensorFlow, right? At the core, like you see in the middle, there's the core execution engine that's written in C++ for raw performance, right? We definitely want to extract as much performance as we can out of wherever it's running. On the front end, we support many different languages depending on whatever the developers want to build things in. In some cases, it might be C++ because they want the absolute last of performance. But in other cases, it might be Python because the data scientists and the researchers, that's what they're most comfortable with. And they want to really try out many different things. They don't want to have to recompile things and so on, right? And the way we've built the core is to enable supporting many, many new languages as well. In fact, we are working with the community to add support for many different things. People are interested in Java, in JavaScript, and Scala, all kinds of things. And you'll see support for more of these building up over time as well. Now, one of the things that the core execution engine does is it abstracts away whatever the underlying devices are. So it actually runs on all kinds of platforms. It can run on your Android phones, on iOS phones, on all kinds of iOS devices. and on your workstation, on your data center, et cetera. It's it's pretty platform independent that way. So you don't have to worry about what platform you're using or where you want to deploy. You can use it everywhere. The core was built. Our goal was to build it for machine learning, but the core is very general purpose, and in fact, people are interested in using it for other things too. But I'm going to focus on the machine learning aspects of it. And the basic idea being that really makes it really, really flexible. So even if you want to do machine learning, it allows you to expand and try out all kinds of things that you would want to do. So that's great. Seems like a great product. One question we always get is, Google uses it so much. Why did we open source it, right? So as you saw earlier, this is having a huge impact at Google. So many different teams are using it. We thought this could have a much bigger impact across, outside in the world, outside Google. And it's really important for us to enable the kind of research and, to accelerate machine learning and to do even better than where we are. Yes, we are building smarter things. We are building applications that are learning a lot, but there's a long way to go. There's still a lot to be done. And we definitely want to accelerate machine learning research, and that was one of the reasons why we open sourced TensorFlow at this time. The other part that we think it's really important, and we've seen at Google, by having this one platform that goes from data scientist to the developer, is that it speeds up production deployment. Once you make something, once you have something that's working, you really want to deploy it as soon as you can. You don't want to wait another quarter for the developer to build something that can be deployed in production. And this really helps with that. So digging a little bit more into that, who is it for? It's really for all kinds of people. And in this case, we talk about the researchers, developers, and the data scientists. And what the researchers do, of course, is they want to try out new ideas. And this provides the flexibility for them to do that pretty easily without having to worry about the underlying frameworks, the performance, et cetera. It just comes for free. Now, the data scientists, were probably overlapping with researchers, et cetera, can leverage the growing library of models that we've built. And what we are doing is, as we publish papers on new research, we're also going to publish real code that can be shared and collaborated with. Now, other data scientists can leverage that, customize it to their needs, or train it on their specific data, and really gain a lot from that. Once that's done, once they have a model and some that works really well, that gives great results, then the developers could take the same API and use it to deploy it in production. So here are some examples of applications that actually use it today. In some cases on the phone itself, in some cases in the cloud. Google Photos for one, for example. In this case, you can search by saying a dog, and it'll show you pictures of the dog. It organizes things by the different people, et cetera. And all of this uses machine learning behind the scenes. Another one is Google Translate, which uses a combination of cloud and on application or on device thing. So for example, in the case on the left here, you can just point the phone at at some sign, and you'll be able to just see it translated in your language. In this case, it's converting from, say, French to English. And in this case, you want that real-time feeling, right? You don't really want the user to, point the camera and then wait for 2 seconds before it goes to the cloud, comes back, and then displays this. It actually, in this case, real-time, just takes the image and superimposes the right text on it. And so in this case, having it on device is really, really important, and you can do that with TensorFlow. Another one is just, conversing hands-free. You're talking to the phone, and it can speak the other language for the other person as well. Another one is, in Inbox, we launched a new feature a couple of months ago. It's called Smart Reply, where if there's a small small email that you got, and you have a very, very simple reply that you could send, it's going to give you some suggestions, and you can just click on the suggestion and take it if you want. And it makes it really easy to reply to emails from the phone when all you want to say is, OK, I'm going to be there, or in this case, say, I'll check on it, or something like that. Another one is Google Keyboard, where it predicts what you're saying. For example, you might swipe on the keyboard, and it's going to try to figure out what word you have and what word you're trying to say, and it can do that using machine learning. So one of the things I wanted to leave you with is, I show you showed you all these different applications in different areas that we've been applying machine learning. All of these applications today use machine learning in one form or another. And this is not a small list, right? People say that the future is going to be smarter, and in the future, in a few years, we'll have very smart applications. I don't think that's really true. I mean, yes, they are going to get smarter, but you already have smart applications today. You already have smart products today. And you really want to think about how can you make your application smarter when you build the next one. If you're building an app, if you're building a cloud platform, whatever you're building, you really want to think about machine learning to see how it can help you make your next application smarter. Thank you.
Thank you, Rajat.
Thank you.
And we have one more speaker for you today. I'd like to welcome to the stage Chandu Thoda, who works as an engineering director for geolocation and local efforts at Google.
Thank you, Timothy. Good morning. So today we are going to talk about beacons. How many of you have seen beacons? How many of you have used beacons? Okay, hopefully we can change that after the session and after the conference. So beacons are not new. So they have existed for a long time. And in fact, the platform that we have built at Google called Eddystone is a name that has been derived from a real lighthouse that was built off of UK some 300 years ago. Beacons have been critical and fundamental infrastructure in providing context in real life. Whether you are sailing the seas, that's where they were used some 300 years ago, and even today there are a bunch of beacons, that the lighthouses that people use when they are in rough seas. But there are also beacons that people use when they are navigating on the roads. So if you are using any GPS nav unit, most likely you are using a bunch of beacons in the sky. And these are what we call GPS or GLONASS or any other system that have been designed to provide this context. And the context is not necessarily just about precise location. So even though most of us actually think, whenever we think of a GPS or any beacon, we think of that as a tool to provide precise location. But the reality is that they can provide a lot more context. Even in the case of GPS, you get obviously a precise lat long, but also you get the heading and the direction and so on and so forth. So there is a lot more context that is provided by beacons to your applications that you're using. But here is a fact. We have all these navigational aids and contextual aids that are present they have been present for hundreds of years, and they are present in our life today through various means. But the reality is most of them are designed for outdoors. Whether you are take lighthouses or GPS, it's all for outdoors. None of that works indoors. And the reality is that 90% of our wake-up time, the active wake-up time, we spend indoors. And for that, and also because we use a lot of mobile devices with us all the time when we are indoors, we need a better system that can provide us that precise location and context so we can build our apps that can be smarter and useful. And when I say precise location, you are actually thinking of lat longs probably, but that's not actually true when it comes to indoors. There is not a really meaningful application to lat longs, for example, in this conference center. What you would like to understand in terms of a precise location when it comes to indoors is a semantic location. What it means is that I am standing here on this stage. This is a semantic location, the stage, right? And you are sitting in that chair. That is a semantic location. You being able to understand semantically where you are in relative to the physical space that's surrounding you is basically where we are going to use beacons to provide that context. That leads us to many, many applications that we are actually already seeing today in the market. Whether you are in a shopping mall standing next to an aisle, whether you are at the airport trying to find out your next flight schedule or trying to pull up your boarding pass, or whether you are at a museum trying to understand what the painting is about. All these applications are built on top of this understanding of precise semantic location understanding indoors using some type of beacons. And that's where BLE beacons come into picture. If you think about the technology that powers all of this is built on top of Bluetooth technology. Bluetooth 4.0 is the specification published by the Bluetooth Consortium, and this is an open standard. And the real promise of this technology is that you don't need to pair with a device, and these devices, anything that implements Bluetooth Low Energy Protocol, are going to consume very small amounts of power to operate, and these are one-way transmitters. That's the most important thing, because there are lots of privacy concerns about this technology. When it is a one-way transmitter, the device itself is not doing anything. It's only emitting its ID, and occasionally it's saying, hey, I'm here, and that's pretty much what the beacon is saying. And then there is a small payload that you can use in terms of configuring these Bluetooth beacons. That's pretty much it, right? So you have these Bluetooth beacons, one-way transmitter, built on top of a publicly open defined standard, and then they are configured to send messages one way from the beacon to your device on a periodic basis. That's all there is to it. And based on that, we have built a platform to extend the capabilities of these tiny devices, beacons, and make it easier for you developers to build applications that both on iOS and Android to make them more contextual. So the way that we set out to do it is, look, the beacons are open, and the number of applications that needs to be built are going to be very varied. So why don't we start with a very open format? What it means is that each beacon can have a various types of frame formats. What it means is that a beacon can emit its ID, or it can emit its URL, or it can emit something else. That 20 bytes of payload, remember from the last slide? So basically, that's the payload that we are going to use, and define a series of use cases together with the community. So that's basically where the open comes from. And we also wanted to make it open source, so you can help us extend some of the frame formats, etc., so which we'll talk about. And then we also wanted to make it cross-platform. So it's not just works for Android, but also it works efficiently on iOS. So these are the key tenets of Eddystone Beacon platform that we have built. So as I said, this is open source. Open source means that we have chosen to open source the frame formats, the SDK, the samples, all of that on GitHub. So as you can see, there are more than 165 commits to date, and we welcome all of you to come work with us and extend the Beacon platform on GitHub with us. And then the frame formats. Frame formats are the fundamental elements of the entire platform. So if you stick a beacon, you can configure that beacon to emit multiple frame formats. What it means is that you can use the same hardware to operate in different modes. So one way is, let's say you take a beacon and you stick it on the podium and say, hey, the podium I'm going to assign an ID, and semantically I'm going to define that this ID means that this stage. And you are going to use that to emit, let's say, once every 10 seconds. And then same beacon, you can also configure that to emit a URL assigned to the same beacon once every 100 seconds, and so on and so forth. So you can use the same hardware and apply various frame formats. So your application listening to that beacon can make use of these different frame formats in building different experiences when mobile apps or users come near them. And we are also working on a series of new frame formats. So this is where, again, if you guys have a specific use case or scenario that you want to work with us, we welcome you to come and contribute to some of these frame formats that may be useful for the rest of the community. And the last one, the key tenet of the Eddystone platform, this has to work both on Android and iOS. So we have nearby APIs, the SDKs available to you both on Android and iOS platforms. And by using these tools, it's fairly straightforward for you to implement your app. If you are programming something on Android, you probably are going to use exactly same paradigms of nearby messages and subscribing to these channels and responding to beacons. All these concepts are going to be exactly the same on both platforms, and that makes it really easy for you to build apps. And how does it all fit together? So there are three layers. There is the beacon hardware, as I described. These are the tiny devices that come from many of our partners. And then there are mobile SDKs. And then there is a cloud. I lost the mic. So the cloud service is where you are going to add some more meaning to these beacons. What it means is that, let's say, as I said, if you stick a beacon here on the stage, you can have that ID have a definition of semantic location. So that definition can exist in an app offline, or you can store it in the cloud and say any app that sees this ID have to hit this cloud service and get the meaning of that beacon. And that's where the proximity beacon API service is going to be a hosted cloud service for you guys to register your beacons and attach a bunch of metadata, whether it is semantic location or whether it is a precise location and so on and so forth, so your application knows which beacon they are listening to and then how to react to them. So the way that you would actually proceed with the platform is you take a beacon and you provision it. Provisioning means that you are going to define pre-configured sets of at what frequency you want to emit the ID frame, at what frequency you want to emit the URL frame if you have it, and at what frequency you want to emit the telemetry frame, and so on and so forth. And once you have defined that, then you will register with a Google Cloud service and say, hey, this beacon that I'm going to stick here means the stage at the Strand. And once the definition is assigned and once the metadata is assigned, you are ready to go with your app. You can take any of the SDKs, Android and iOS, and build your application. And the way it works is the data flow is pretty simple. The beacons are one-way transmitters. They are constantly emitting their ID to your app, where the phone is hosting. And once your Android or iOS phone that the app is running and it is listening to this any incoming beacon advertisements, and once this message is heard, basically the app going to look up the Google Cloud Service and say, okay, what does this beacon mean? And Google Cloud Service will tell you, here is the metadata you have attached to your beacon. You said this beacon means the stage at Strand or your thermostat at your home, and so on and so forth. Once you have that metadata in your app, you are going to make use of it and do something with it that's interesting to the users. So there are more than 18 partners that we have lined up that can provide these beacons for you. These are all certified partners. Certified means that they conform to the Eddystone standards in terms of implementing all the frame formats, and they also work with our SDK right out of the box. And some of the things that at Google we are doing with this technology, we are obviously wanting to take advantage of this to the fullest extent. So we have integrated this beacon platform into Google Maps on Android, and some of the features that we are just rolling out. We have launched a pilot in Portland where you walk up to any transit stop and you get the real-time transit information in less than 500 milliseconds. So the entire thing was built on top of Eddystone platform, and this is on an Android. And there are Android Google Maps. There are more things that we are trying to do, obviously with Google Now, where you walk into a place and you get notifications, and some of you may have already seen some of the notifications that pop up at a place. So those are the things that we are working on as well. All of this brings us back to one thing, which is, as Timothy has alluded to as part of IoT, beacons are a great way to provide that context, especially indoors. When you are indoors, you are trying to provide the semantic meaning of what you are interacting with or what you are standing next to. As I said, it could be an aisle in a shop, or it could be a thermostat at your home, or it could be a point of sale at your favorite coffee shop. All these things are going to be immensely useful in terms of providing that context into your app. So this is where beacons come into play. And this is where you guys are coming to play in figuring out what can be done to extend Eddystone into providing those powerful contextual apps. With that, we have plenty of other resources available at this conference. We have Ask Me Anything, I think, session tomorrow, and then there is one more developer-oriented session later on today. Obviously, we would love to see you there. There will be members of our team waiting for you to answer any questions. And also, I think Timothy obviously didn't want you to leave empty-handed, so he'll be here to tell you a little bit more about what you got this morning.
Thank you, Chandu.
Thank you.
That was a big box. So what's in the box? Well, we didn't want you to leave empty-handed. In addition to the great sessions and technical information that you're going to hear today and tomorrow, we wanted to make sure that you had the right tools to start building today. So we're giving you a Brillo and Weave development kit, a beacon, and of course, cardboard. Can't leave a Google event without cardboard. Today, with these tools and sessions, let's start our journey together beyond the Internet of Things. Thank you.
Hello, good afternoon, everyone. I'm Andrew Warren. I'm a product manager on the Weave team, and today we're going to be talking a little bit about kind of what Weave is and some of the developer components to it. And then in a little bit, Sam is going to join me out here, and we're going to talk about Brillo. And we're going to try to leave some time towards the end for Q&A as well. And there are some mics along the sides as well as on the balcony for folks to line up for that if they need to. So without further ado, let's dive in. Before we get into really what Weave is and kind of what the components there are, I want to talk a little bit more about the context of some of what we're seeing of shifting user expectations in this area. Because that actually informed a lot of what we were doing from the Brillo and Weave side, and I think it'll help to understand why some of the decisions were made, particularly around privacy and security, but some other things as well. So we're seeing actually a pretty quickly shifting landscape in terms of user expectations around devices. And here I don't just mean connected devices, but even the devices that people normally have in their homes, at their offices, in a variety of different places. And one of the first and the most visible ones of those is around the user's expectations around the experience with their devices. So there was a time when, in order to bring a device into your home, it was generally a look through the manual, figure out what magical combination of buttons and arrow keys to press on the top of it to get it set up. Sometimes you might have to download a Windows application, and then you'd have to go through it finding the IP address of the device on the local network, and then opening up a browser to the onboard web server. And thankfully, those days are fast retreating from us. But what that means is that users are also starting to expect that there's better experiences with regards to getting devices out of the boxes, that there are better experiences with regards to getting these devices set up and then ready to use, and then actually starting to use those. And that actually comes into the second piece of this, which is really about mobile experiences playing a larger role in users interacting with their devices. Again, back when users really needed, in order to have their computer talk to their device, that kind of experience didn't really work out very well because the computer wasn't very portable and often neither was the device. Mobile has started to change that a bit. It's easier to carry around your mobile phone with you and interact with devices in whatever room of the house you're in or the device you're talking to is in. We're also seeing, as part of that growing interaction between mobile and the devices that we have in our homes, the addition of increased intelligence and kind of adaptation to the user's circumstances, to their behavior. We now have vacuum cleaners that know when we are or are not home and have the ability to learn our floor plans. And again, this is still very early days for a lot of that, but it's starting to shift user expectations around what their devices should be doing for them. And that's something that we have to take into consideration to some extent as well. Another side of this that we're seeing as we're kind of looking over at some of the landscape here is that these devices are starting to get better and better over time. And the user expectations are starting to shift to orient around that as well. This really kind of started to some extent with the internet and with web applications and web services getting better each day. You come back and reload the page. And then that carried over to the mobile landscape, where the internet also allows the mobile experiences to get better day by day. And if you have a problem, if you have a bug, if things don't work quite the way you want, take the next app update and everything works better, or you hope so at least. And so that kind of expectation is also starting to bleed over a bit into the connected devices space and the consumer devices space, not just because the device itself maybe gets better, but also the experiences that come along with it are getting better because you can update those mobile apps and these kinds of things. The next piece is actually probably, to some extent, the most important piece of this, which is as connectivity starts to come to devices in the home, in the office, and these kinds of places, with it comes all of the security and privacy considerations that have dominated really the rest of the digital age altogether. And so devices now have to play in the same security landscape to some extent, and user expectations around security and around privacy and ownership of their data becomes just as important for these kinds of devices and for consumer electronics as it really has historically for computers and for mobile devices and these kinds of things. And the last piece is a little bit on the technical side in addition to on the consumer expectation side, but there's really an increased expectation that these devices can actually update. Historically, devices, once they hit the shelves, were really frozen in time. You bring a device home and you can tell what year a kitchen was last remodeled just by taking a quick look at the devices in it. But we can't really get continuous updates and continuous improvements to the experience if there's not an ability to update these kinds of devices. And more importantly, devices can't sit in the home for 2 years, 5 years, 10 years, and continue to be secure with the constantly evolving security landscape of the web if they're not updatable. And so there's an increasing expectation and reliance on these devices to be updatable over the air. So this is just, again, some context of some of what we're seeing looking out over the expectations landscape from the consumer perspective that help to inform some parts of what you're going to see with regards to Brillo and Weave. So with that, let's go into a little bit on kind of what Weave is, as well as the experiences that are actually that are part of Weave. And then we'll lead right into some of the components that are available for developers, because that's really the most important part here. And there will be several more talks over the course of today as well as tomorrow, getting into not only specifics of the developer experience for parts of these, but also around actual code labs so that you can get your feet wet and try to play around with a lot of this. So the best way to think of Weave, I think, is as an application layer protocol that tries to include a number of pieces that are fairly integral to this kind of experience of building a connected device. These include turnkey support for things like device discovery over a number of different transports, for things like authentication against devices, and more importantly, in some situations, authorization for who or what has access to those devices. It includes provisioning and the ability to get a device set up out of the box and to go from out of box to ready to use as quickly as possible and as easily as possible. And it also includes real-time communication in both directions to try to make sure that if a client application or a service wants to tell a device, you need to do this thing now, the device knows as quickly as possible that it needs to do that. And likewise, in the opposite direction, if the device's state updates, if the status of that device changes, I'm now broken, the temperature has changed, any of these kinds of things, it's important they be able to notify applications and services that are subscribed to that state as quickly as possible. So this enables a variety of different kind of experiences that we're trying to make sure are built on top of this and to make sure are easily accessible to the user. The first, and one of the more important ones of those, is around the device setup experience. So one of the things we found as we were talking to manufacturers is that actually this is where a lot of users fall off the connectivity train. A lot of these devices have different ways of setting up the device. Again, it's still a combination of directional keys on the top of the device or some combination of those in an application that you have to find in the store and make sure you pick the right one with the right name and then download and install and all of this kind of stuff. And it gets very cumbersome. And then on top of that, the user frequently needs to remember their Wi-Fi network password and a lot of other details that then just makes this a very difficult process. So talking to manufacturers, we actually found that this creates a lot of support volume. And that this creates a lot of user confusion that ultimately leads to people not using the advanced features of their devices. So what we tried to do was just bake this directly into Weave and to make it a simple, easy, consistent experience for users out of the box. So without, and you can see kind of parts of this experience here on Android, without the user needing to install an app, without the user needing to go and find anything to begin with, they can just come directly to this experience, find the devices around them that are available to set up, choose the network that they want to get that device onto if it's a Wi-Fi connected device. And importantly there on Android, we're actually able to, if that mobile device has connected to the network before, just pull the network password directly from the system with the user's permission to make sure that the user doesn't have to go and hunt down the little notebook where they wrote down their Wi-Fi password 2 years ago or things like this. And then take the user to a place where they can basically choose an account if they want to control authenticated access to this device, and then just get the app and go directly into the experience that came with the device. So really the aim here is out of box to ready to use in less than a minute. And we're trying to make sure that that's also a very consistent, simple experience so that users don't have to relearn it every time they get a new device. As long as they pick up one of these devices in the store, they should know exactly what to expect in terms of getting it set up and ready to go. There's a few other parts of the experience that we also consider to be very important to kind of align this protocol around. The first of which is being able to share access to these devices. So mobile devices today are very one-to-one. It's a personal device. And although you may have lots of accounts on it, oftentimes all of those accounts are you. And in very limited cases, they're shared between a number of different people. These devices typically live in our homes and in office spaces, which are very much shared spaces. And as a result, being able to say something like, this is my family, I trust them, they all have access to this thing, is a very important capability to have. And likewise, being able to say, these people are not my family, I do not trust them, they are my tenants, and they should not be able to control these things and change the cost of washing machines and dryers, but they should be able to see them and to see whether or not they're currently in use so that they can decide when to go down and do the laundry. That's also equally important. So we've tried to make sure that from the ground up, these devices are shareable, and that it's very easy to users to grant access at different levels to different people. The next part of this that's important is making sure that this protocol, and especially for that bidirectional communication, is fast and secure. Security obviously is a fairly important piece on any transport, and that has to be taken care of as well as in a privacy-centric fashion. The other side of it, though, is speed. A lot of people today, when they flip a light switch or when they tell their microwave to turn off or these kinds of things, expect instantaneous response. They expect the devices to do what they say and to do it immediately. Once you get into connectivity and into a variety of different wireless transports, that starts to become a higher bar to hit. And so part of what we've tried to do is we've tried to weave on top of both the local network and remote hops through the cloud, and adding additional transports as we go along to try to make sure that we can always pick the fastest route to get a message to the device. So if your phone is on 4G, and your light is on the local Wi-Fi network, or on Brillo, or in this case on the Wi-Fi network, then the message would take a trip through the cloud and we'd get it there as quickly as possible. But if your phone is on the local network as well, that message shouldn't bother going to the cloud. It should just go directly to the light, and it should go as quickly as possible to make sure the user feels no noticeable delay there. So that's part of what we mean by fast communication. The second piece of that that's important to us is consumers shouldn't have to know that, and they shouldn't have to understand that. So you may have a variety of different wireless protocols being used in your home. You shouldn't need to know anything about them in order to use these things. And all of this should be transparent to the user. The other half of that is that over time, we're hoping to make this relatively transparent to the application and the service developer as well. Because learning the different APIs for every different operating system and platform you're building on, for controlling the Bluetooth radio or Wi-Fi or any of these kinds of things, is a chore that really shouldn't be necessary. So we want to make it as easy as possible for you to say, take this command, send it to this light, find the best way to get it there. And that's something that we're trying to bake into the different client libraries that we make available as well. The last piece, or not quite the last piece, but one of the other important pieces of the consumer experience that we feel is fairly important here is that users actually have a choice in applications and experiences. So one of the things that we've noticed, and you've probably noticed too, with Google services and applications, is we can build a fairly good experience for about 80% of people. And then what made that a great experience for them makes it not such a stellar experience for another 20%. The things that make it good for some people don't make it so swell for others. And so it's important to us, as we're building out this platform, that we acknowledge, especially as you start to have a variety of different devices around you, a variety of different experiences, that from the user perspective, there's not going to be a one-size-fits-all solution. And we're not going to build a one-size-fits-all solution, and manufacturers aren't going to build a one-size-fits-all solution. There isn't going to be that in this space. And so we want to make sure that this platform is very, very open and allows developers to build all kinds of different rich experiences that make sense for different types of users and different kinds of contexts. So the one other piece on the user perspective, from the user perspective, that's important for us and that we've tried to make sure is enabled by this protocol is how to handle app and service access. So we talked a little bit earlier about granting users access, but what does it mean once you actually get access? Does that mean everything on your phone can talk to these devices? Does that mean if you grant a particular application access, it gets full access to all of your devices? And the reality is there's different devices and different categories of devices that are more privacy sensitive or that are more security sensitive or safety sensitive. So just because you've bought a toy that's a lot of fun and that you want to use an application with, doesn't mean that application should also get access to your oven or to your scanner if you happen to have left tax documents on it. So one of the things that we're trying very hard to make sure that we have enabled through this is the ability for a user, well, for an app developer to start, to be able to say, these are the types of devices I can work with. These are the types of things I need to be able to do with these devices. And then for the user to easily grant that access without over-granting a lot of additional access that the application really doesn't need, and that the user shouldn't really need to trust that application with. So this is another side of the access controls and permissions piece of it. So going into the components a little bit of kind of what comprises Weave across the board. The first and one of the key pieces is the Weave service as a whole. So by this I mean the Weave Cloud service. We've built out a service that users can register devices to that basically provides that cloud hop. It provides a set of REST APIs that make it very easy for web app developers and for web apps and services to interact with devices and be part of this ecosystem. It also provides that cloud hop when a user's on their phone and they're on a different network than the device, or when the user's not at home but they want to double check that everything's going well. These kinds of things go through this cloud service. And this is, there's a flip side to this that I think is very important to mention, which is this cloud service allows remote access, but the user doesn't have to use it. So the user always has the choice, and you might have seen that during the setup flow, of whether or not to associate any kind of account with this, and whether or not to enable any kind of remote access to their device. And if they choose not to, that's fine. All of these applications will still work in the local environment without any modification. So this is one of the things that we feel is very important here. The user should always have the choice of whether or not to associate their device with the cloud and have that type of remote access. So that's the cloud side of things. On the device side, naturally implementing this kind of protocol, especially with all of the security considerations and everything across different transports, is a little bit of a mess. And so we've tried to take on as much of that work as we can from the Google perspective, and we've built out a portable C++ library that can be taken into devices and used to enable them with Weave. We've tried to slim out as many things that we can that might already be on an embedded system to make sure that we're not adding unnecessary resource usage. And in order to do that, we've also provided several wrappers that make it easy to integrate this library onto common systems. And so naturally, Brillo is one of those. There's an Ubuntu wrapper available. And we'll be adding additional wrappers for additional system types as time goes on to make it easy to build that kind of thing into the devices themselves and into and to make it easy for OEMs to build those experiences out. The next piece of this, beyond the cloud and the device side, is naturally the client. And by client here, I mean not just mobile client applications or desktop client applications, but also web applications. This is an area that, of course, is critically important if we want to have an ecosystem of these things. And so on Android, as I mentioned, we've built the setup directly into Play services to make it easy for users to get started even without an app. And that goes back to Gingerbread. We also provide an implementation of the full protocol there that your client application, your Android application, can call into in order to discover devices, send commands to devices, query state updates, these kinds of things. The other side of this is, of course, iOS, which is very critical as well. People use a lot of different phones in their homes, and sometimes the same user has multiple, but other times different users in the home have different mobile devices. And so it's important that we provide all of that same functionality for iOS. So there, the setup flow is built directly into the client application since we can't build it into the system. And similarly, you get all of the same access to discovering devices, interacting with devices, subscribing to updates, et cetera, from iOS applications. And the last side is, of course, web applications and services. And we're actually very excited about the potential for new applications and services that interact with a variety of devices to be built. And so similar to other Google APIs and web services, we've provided a variety of different client libraries for use in a variety of different languages, since there's such a diversity of frameworks and languages in use and building out web applications. Users on desktop can still set up devices. There's a Chrome app available from that, but we anticipate most of those users will be using mobile phones to do that. The other couple of things that we provide are a few things in the area of developer tools. So we'll have a couple of other conversations about this later. One of these is the command line tool, which basically just allows you to register devices, send commands, query state updates, these kinds of things from the command line, either over the local network or remotely. And this makes it very easy to start testing things out and further to start building automation, and especially test automation from more popular environments for that. The second piece, which actually we're very excited about, and you'll hear a little bit more from Lawrence and from Sam later today, is the Weave Developer Console. And this both allows you to easily prototype devices before you've even built a client application for them, to start registering them, testing them out, sending commands, seeing the state in real time, these kinds of things. And it also provides several features around fleet management that we hope will lead to more of that continuous improvement that we talked about earlier. So in particular, this is things like access to aggregated metrics about how the fleet of devices is being used, to let you understand kind of how your users, what features are popular and what features are unpopular, and whether you have crashes going on and these kinds of things, so that you can improve your devices over time. And then on top of that, as I mentioned, over-the-air updates are very important. Again, we'll get into this more a little bit later, but we're trying to make that very easy from this developer console as well. The last piece that I want to talk about from the Weave development side is interoperability and schemas. So everything that I've said so far during this presentation has made it sound like we're building a wonderful platform for building new silos on top of. And everyone knows that what the world really needs right now is more silos of individual app experiences, because we all really want to have one app for every device we bring into our home. We've tried from a protocol standpoint to build in interoperability at a very core layer of all of this. We've tried to make sure that you won't end up in that situation where you have one app per device. And part of what we're doing for that is we're working very closely with all of the manufacturers that we work with to build schemas that represent a device's capabilities, that represent the types of states and commands that a device needs to use, so that we can provide a stable interface to those devices to developers on the other side, application developers, service developers, so that when you get access to a light, you know, based on the schema for that, that you will always find an ability to turn the light on and off for every light that you have access to. That you'll find that some lights are dimmable and some aren't, but because of Weave certification, if the light can be dimmed, you will have access to it, and you will have access in a stable way so that you understand exactly how to dim that light. There's a flip side to these kinds of schemas and interoperability, which is that if we're not careful, we'll end up boxing devices into the types of functionality they have today, and basically ensure that that's the only functionality they can ever have. So another part of how we've addressed schemas is ensuring that they're extensible, both in terms of capabilities for very popular device types, as well as in adding new capabilities entirely that aren't related to current device types. So manufacturers can add new differentiating features, come up with improved ways to do things that are outside of the current schemas, as long as they're not blocking off the core functionality to you to use the typical core functionality of that type of device. So this allows these devices to continue to evolve for more interesting and exciting things to be added to the ecosystem of devices over time without cutting off the interoperability piece. And the certification program kind of keeps those things separate and ensures that core interoperable devices are always consistent. The one other thing that I think is worth mentioning there will be some device types that are totally new. There will be some device types that aren't common in homes and may not make sense for us to define a schema yet for, just because it's very early days. And so for communities that are trying to build those types of devices, the schema format does let you come up with new commands and capabilities and states, and you can have a totally custom device as long as it's not of a type that already is out there and has a schema for it. And so for communities building new device types, you can think of where maybe 3D printing was a few years ago. Those communities can come together and start to agree upon a way to represent this device and can get interoperability using these schemas in their community, even before a proper schema has been kind of created as part of this system. So we want to make sure that this whole thing is very open and extensible to that as well. So with that, I'm going to hand it off to Sam. Sam is going to talk to us a little bit more about the Brillo side of things and what we've built out there. And then again, we'll leave a few minutes towards the end in case you have any questions so that we can answer those. Thank you.
Thank you, Andrew. Hi, everyone. My name is Sam Beater, and I'm a product manager on Brillo. So today I'm going to walk you through some of the details of Brillo and how it can make the development of your devices easier and also make them simpler to maintain. So first, I want to talk about what kind of devices do we mean when we talk about Brillo devices. So one problem with the Internet of Things is that it means everything to everyone, and it means a lot to us too, but here's just one taxonomy of how you can break up the classes of devices that we're talking about with Brillo specifically. One important thing to note is that with Brillo, it's not focusing on terminals. And one reason for that is that Google already has other products, such as Android for tablet, Chromecast, Android TV, etc., that are fixing a lot of problems with terminals. But there's this whole class of other devices where we think Brillo is a perfect fit. So there's the idea of human augmentation with wearable technologies. There's robotics, there's drones, there's enchanted objects that can power your smart home. So as you as developers are trying to build some of these devices, we want to make it as easy as possible. And so before I go into the details of Brillo, I want to first break down a few of the common developer challenges that as we're making Brillo, we want to make sure that we solve. So what are some of these common developer challenges? One major component that we want to focus on is security. So Andrew already briefly mentioned security, but we think that any IoT device needs to have a really strong security story. And the reason for that is you need to retain the trust of the user. They need to trust that they can use this device and it'll keep their information private. We think it's hugely important also because some of the devices that are currently in the marketplace don't necessarily have a strong enough story with respect to security. And so this is a really big deal because if your device isn't prepared for any potential security flaw, you need to have a plan before the flaw comes into place. Once it's the day that once the news story comes out about this flaw, you only have a day to make this change. You can't have it rolling out over the coming months. So this is a really big deal, and we think that for IoT to be successful in the long term, this needs to be stronger in every device that's out there. So what's the next common developer challenge? Not only does this device that you make need to be constantly connected and secure, but it needs to actually be delivering additional value to your users. So both your company and the end user are going to expect additional functionality, additional features, and new information that they can get from these devices. Next is staying competitive. So when you make these IoT devices, they need to be secure, have new features and everything, but at the same time, you can't be increasing the cost of this device by very much. In order to be successful in the marketplace, the cost of these IoT devices need to be the same or very small amount more than the non-IoT counterparts to this device. Finally, you need to do all these things at scale. So we think Brillo is a perfect fit to address all these challenges. So what is Brillo? What is Brillo? Brillo is an Android-based operating system that has built-in support for Weave. Because Brillo is Android-based, if your chip vendor already supports Android, then they can support Brillo. And this allows for a greater ecosystem of these compatible hardware devices, or development hardware. It also allows you, if you need to switch which hardware you're using, it's much easier with Brillo because there's a lot of options out there. Next, there's a Brillo Developer Kit, or BDK, that we give you to make your development process easier within Brillo, and it allows you to configure your operating system and build the device image. You can change anything about the device image since you're building from source, so we're really not going to stand in your way with anything you want to do with your device. Finally, there's a set of features such as updates, metrics, and crash reporting to continue interacting with your device once it's already been launched. Now let's go through all these in a little bit more detail, starting with what it means for Brillo to be Android-based. So Brillo is based on just the lower level layers of Android. What this means is that it's based on the non-Java native layers of Android, and it's a stripped down version of Android that is specifically made for connected embedded devices. Brillo also has this well-defined board support package and product concepts that make your device much more maintainable. So because the board support package is completely separated from your product code, you can update each independently. This also makes it much more easy to plug in a new BSP if you ever want to. We also focused on making Brillo really modularized. So what this means is that, say for example, your device has no need for graphics. You can take out all the graphics components, and this will make your end device much slimmer, and the end product will be cheaper, which, as we mentioned, is really important. Also, all of Brillo is open sourced and developed in the Android open source project. It's there right now, so you can, totally transparent exactly what's going into Brillo. You can go check it out. So these are all features that you get because Brillo is, Android based. And next, I want to talk about security because we also worked really hard on making sure that we have a strong security story with Brillo. So Brillo has a verified boot architecture that can be used to check all executable code. This verified boot architecture helps ensure that the image you put on the device is the same image that runs. Brillo also has software fault isolation by default. So all the Brillo built services are sandboxed and deprivileged, and you have the capability of making it so that your devices run the same way. This makes sure that if there is a problem in one of the components of your device, it won't make it so that there's a problem in the whole device. Sooner or later, there might be a security problem with your device, and for that, Google provides ongoing security fixes with supported releases. We also have our updates go all the way down through the firmware and bootloader, so that when we provide fixes to these devices, it'll completely fix the problem. It'll go through the whole device. So this is our story for security. We have another talk specifically on security because we think this is really important for any IoT device. And next I want to talk about the Brillo Developer Kit, or BDK. So Brillo provides a number of tools that will make your actual development process easier. Brillo has standard embedded development architecture using ADB and Fastboot. There's also this out-of-tree and configuration model where all of your code is in your separate tree, which allows you to continue using all of your existing development tools and revision system. And so it's entirely in your own tree. You control it completely. But at the same time, you build the device image from source. So if there is a specific kernel configuration that you want to change, you have that capability. And for those who know Android development a little already, there's some other native development tools that we provide that makes your life a little easier. Brillo uses Binder, and so we give you some C++ ADL generation that you can use. There's also a init and security configuration and unit and integration testing. So these are all ways that make the development process within Brillo easier. But as I said before, once you deploy your device, you may want to continue improving it. And so for that, there's updates. So with Brillo, you can send updates to some or all of your devices over the internet. This allows you to continue improving your device and fixing bugs after launch. It's built on the same infrastructure as Android, so it scales really well to all your devices. You can rest assured that millions of devices will be able to update effectively. Since these IoT devices are constantly connected to the internet, you don't really want to have these updates interrupt the flow of the devices. And so to that end, we have these updates download in the background, and you can control when the device reboots to apply the changes. We also make sure that the update payload and the image are independently secured. What this means is that the download integrity is maintained separately from the image integrity. So the payload integrity is secured by Google so that you know that you're downloading the actual changes that you pushed out. And finally, the image integrity is protected by you with your private key, so you know that what's running on the device is the change that you made. So updates are one way to interact with your device once it's been in the field. However, you're going to want to also receive information from these devices. And to do that, we have the developer console and metrics and crash reporting. So with metrics and crash reporting, you can see with your devices how they're performing in the field. So for example, let's say you have a set of refrigerator motors. And in this case, the refrigerator motors are using 10% more energy than you would expect. With this graph on the left, you can imagine this showing the efficiency of these motors, and you could see right there, really immediately, that they're using more energy than you would think. There's also crash reporting data that you can see for any things that are failing about the motor. So these tools are, we think, really useful to quickly iterate on bugs and improve the device. Because of the update tools I just mentioned, if there is a problem, you can provide a fix and see the results in the developer console, and you can go back and forth and iterate to fix the problem in much quicker than before. The alternative of waiting for users to report an issue or having to go into the field yourself costs more and is just less effective. All this data is aggregated in a way that retains privacy for the end user. So all these features I just mentioned, security, the Brillo developer kit, updates, metrics, and crash reporting, are made so that your development process is easy, but we realize that it's also important to make sure that the process of taking your existing work and bringing it to Brillo is easy as well. So for that, I want to touch on adoption. We worked really hard in Brillo to make sure that it'll exist well in your existing workflow. So because Brillo is Android-based, there is this wide set of industry support, so you can likely keep your chip supplier. In addition to that, if you need to change hardware because a different set of hardware will make your device more effective or cheaper, we make that really easy too. Secondly, most embedded devices today are already built using C and C++, so you can likely keep your language as well. In addition to that, because of this out-of-tree concept, where all of your code is in a separate tree, we're not going to stay in your way if you want to use a different language. Next, Brillo has wide support for a large set of third-party libraries. So these facts together make it so that the process of bringing your code into the Brillo environment as easy as we can make it. And so finally, I want to go through a thought exercise. Suppose that there's a major security vulnerability in a single library in all of your IoT devices, and you need to fix it. If this is a major threat, you need to get this fixed out tomorrow, not over the coming months. So here's our task. Patch this newly discovered vulnerability in a single library of all of your company's IoT devices. As you're frantically looking for how to fix this, some of these questions might be running through your head. Do you know if all of your devices are running the same version of the library? Do you know if the patch is compatible with the other system software on the device? Do you know if your Linux provider has given you the patch, or do you have to do it manually? Next, once you have this fix, how are you going to push it to all of your devices? And finally, even after you've pushed it to your devices, how will you know if it's working? With Brillo, we make answering these questions really easy. Once a vulnerability becomes known, Google can identify and quickly generate a fix. All you need to do is download the new BDK, press make, generate the new firmware, and push it out. The staged rollouts will kick in, and you'll see in the developer console as the patch is being adopted by our users. So this process for this very real threat that could happen becomes really simple with all the tools and features that I just mentioned. So I'm going to leave you with our call to action. So everyone here at this conference now has access to the Brillo and Weave developer sites. So you can go on those sites, go and download the BDK, start running through the code labs. We have a large set of code labs that can get you started making your device, trying an idea. And we also have many other talks today that can go into more detail about some of the things that I mentioned. We also have demos later today. And we'll have some time right now to answer your questions. Thank you. So Andrew can come back out here. As we mentioned before, there's 2 mics down here and then 1 mic in the balcony that you can use. So there's the mics there. And
Yeah, the one complicating factor is we can barely see mics. So if we don't catch you offhand, wave really fast.
Quick question. No invitation necessary for using the SDK?
So the question was, is there any invitation necessary for using the SDK, or I'm sorry, the BDK? All of this is open source and is available right now. The documentation and everything is still early access. So you can't get access to the documentation yet outside of this conference. Everyone in this conference has access to this today.
Thank you.
Yes. Is there a question over here?
no, I think there's a question right here.
Okay, thank you.
There's a question about Brillo.
Sure.
If I've got a device, a connected device that has a display screen on it, is there support for that in Brillo, or is that sort of beyond its remit?
So the question is, if you have a device that has a display screen, is that supported by Brillo?
Yeah, sort of, obviously, if you put full Android on the device, you get all the UI with it.
Yeah. So I would say that it's not the focus of Brillo, but these things are, you can make anything work really with Brillo. And so since it's, the product is in your own tree, there are capabilities to have a display screen, but that's really not the focus of Brillo right now. Brillo is improving over time, and so as more and more updates come out, the capability for that might become easier.
Thank you.
Yep, thank you.
Hi. So I'm just I'm really excited to add Weave support to my app. Just wondering, kind of, when do we expect devices to start coming out for being available to consumers? Are there any available now, or what is it, like, year or 6 months or what?
Sure. So around timelines for apps and for hardware relating to Weave. So the general release of Weave will be later over the course of the next quarter or so. In terms of hardware, expecting later this year to have hardware out. And since you have access to the developer site and to more information about things, you'll also have the ability to check there on the types of devices we've built schemas around, so you can figure out what devices you can start building application experiences around easily.
I think we have someone in the balcony.
Yeah.
Oh, yeah.
Yes.
Yeah. Are we restricted to any particular cloud service for using this?
So the question is around, are you restricted to any particular cloud service to use Weave, and presumably also some of the Brillo services. So in order to ensure interoperability and the fact that the users always are able to use these devices from any application they want, devices do need to, if they're certified to use Weave, need to be able to register against the Weave cloud. In terms of building other cloud services and web services and these kinds of things, we've tried to make a very easy developer experience to tie those in so that they can interact with these devices too. And I think this is a similar story for Brillo services.
Yep.
So we provide a variety of services out of the box. You can always, of course, bring along more and add more to your device. We have a question here in the front. Yes.
Does Weave also handle network management, network failure, that kind of thing?
Yeah, so the question was around, does Weave also handle network management, and in particular cases where the device may lose connection to the network or the user may need to set it up to a new network? Sure, and to discover devices on the network from the client app perspective and these kinds of things. So yes, the Weave library for the device side does need to be tied into the network management stack to do particular things like handle provisioning from the device side. It also takes care of if the device falls off the network, making itself available to be brought back on, say if a user changed their network password or these kinds of things. But otherwise, there can be other logic on the device as well that's handling the network stack. From the client application side, the Weave SDKs for Android and for iOS does handle interfacing with the system for handling the protocol over the different transports.
Could also other protocols handle it? For example, if you have the thread, for example, they can handle that?
Yeah, so Weave isn't exclusive. You can use other protocols with these devices as well. Absolutely. Yes?
And where's the list of all of the devices or the inventory of all our devices maintained? Then the BDK?
The list of devices, by that do you mean the schemas that are available for interacting with devices, or the developer boards, or?
The user
Uh-huh. I see. So so the question is, where does the user maintain a list of all of the different devices they have access to and the ability to control that? So we provide a core UI that users can use both on the web as well as on Android for finding the devices they have access to and making sure they have a fallback place to control access to those devices.
Someone at that mic.
Yeah. Couple of questions. So what are the supported network interfaces for Weave? And secondly, what kind of considerations given for offline mode when devices go offline and come back online? Kind of?
Yeah. So around network for interfaces used by Weave and how do we handle offline? So network interfaces, Weave is currently available over the local network as well as through that cloud hub. BLE support will be coming relatively soon over the course of the next few months. In terms of offline capabilities, as I mentioned, it's very important to us that these devices work as well, even if the user isn't registering them with the cloud, even if the user isn't going through the cloud. And so the devices will continue to work over the local network just as well. One of the things that you won't see quite in the set of software that's available for you as part of this early access to folks at the conference, but that's actually coming very soon, is the same layer of access control over the local network as you get through the cloud. So the same ability to authorize particular applications and not others, to authorize particular users and not others, even when the device is offline, to make sure that the user, even if their phone is offline or their device is offline, is still able to get into their home to use these things.
Do you maintain the state of the devices and cache them?
Yeah, so we do cache the state of the device cloud side for remote access. The state of the device is also easily discoverable if you're local with the device and you have access to it. I have a question here on the side.
What kind of security auditing are you going to be doing before a Brillo or Weave device goes out with the name Brillo or Weave?
Right.
And by that I mean not just are you implementing the protocol securely, but also is a default state relatively secure, or is it just really easy for anybody who's wandering past your house to get access to your wallet?
Sure. So the question is around what kinds of auditing are we doing to make sure that devices that have the Weave brand on it or that are using Brillo are secure out of the box. And there's a couple of different layers to that. As you mentioned, certification is a very important place where we do a degree of testing around all of the different kinds of issues that we can from a black box perspective to ensure that this device isn't susceptible to common security issues. A second part is part of the schemas that we define is defining the minimum role necessary for common types of functionality with the device. So as I mentioned, there's different types of access, different levels of access that make sense for different types of capabilities. Each of those levels of access should be relevant to the type of functionality on the device. Like you may want to see whether a scanner is on and off. That doesn't mean you should be able to see what's sitting on the document scanner, these kinds of things. And so that's actually part of the certification program as well, is testing that default state and making sure that it actually implements those minimum roles that are defined as part of the schema.
Is it also implementing minimum roles, or is it also you guys saying, hey, having a default minimum role to see the lock state of anybody is a bad idea? Is that also going to be part of the audit?
Yes, that is. So the question was, is it also just saying having a minimum role for a particularly sensitive state like the lock state may be too sensitive for anyone? The roles go up to a fairly high level, including the owner of the device, and so the way to handle that is a minimum role is owner, and yes, that will be verified as part of certification. So the gentleman, yes.
Regarding home automation, I'm always intrigued. What happens if I install all kinds of home automation using Brillo or Weave in my house and then I move? How do I hand over all these devices to my owner? And if I'm the new owner, how can I make sure that the stuff I just bought will work?
Sure. So the question was around if you have a home full of Brillo and Weave devices and you have them all set up, they're all tied to you, and then you move. And then there's a couple of implications of that. How do you make sure that the other person who's moved in can't get access to your kinds of data or things you've done historically with these devices? And vice versa, how does that new person make sure that you don't have the ability to snoop on them and things like this? So these are great questions, actually. In the first case, the data is, again, all tied to your account. Even if it's fully local and you never associated it with any account, it's tied to the devices you used with it. So that new person coming in isn't going to be able to see anything historical about how these devices were used. The flip case of how does that person make sure that you basically kick you out of the home fully and make sure that your devices aren't spying on them or doing things like that. All devices have to have a way to reset them if you have physical access. So, So there's always going to be a way. Now, there's easier ways for you to actually transition to give that ownership to them. At the moment, the easiest way to do that is simply to delete that device and let it go back into a provisionable mode. At the moment, reprovisioning everything is the best way to do it. We're looking in ways to handle ownership transfer, but there's a lot of security implications that come with that too.
So maybe a related question what the gentleman asked. So whenever today an end user buys an Android phone, they have to create a Google account and to use an Android phone. And whenever there is an OEM publishes a newer version of Android, the user accepts the end user agreement and update the device to a later version of Android. So are we going to have a similar model here that everyone who will use the end devices will need to have a Google account, and they will have a new updates of Brillo or Weave board support package or application through the OEM program, where the end user will update the new, end user will decide whether they want an update or not.
So I heard two questions there. Yeah.
So is the main question that can the user decide whether or not they're updating? Did I understand that correctly?
First of all, will user have a login? And second, does the user decide to update to the newer version of operating system as application both?
Yeah. So I can at least answer partially, and then I think Sam can probably give a little bit more detail on the Brillo side. The user doesn't have to have a Google account to use any of these things. The user doesn't have to associate it for remote access or any of that kind of thing. And if they don't have an account, they should still be able to use these devices in their home without an issue. In terms of the second question of updates, as part of the Weave program, actually, in the certification, we're also ensuring there's an update mechanism in place so that security fixes and things like this can get out to these devices. And so at least on the, from the Weave perspective, there has to be a balance based on device type of whether things auto-update in the background or whether or not the user needs to be there to actively authorize something to the device. Finding the right balance between that friction of the user and also keeping things safe is one of the things that we're going to be working manufacturer by manufacturer and on to try to make sure it works well.
Yeah, and just to add, with Brillo, we are really encouraging, we're making sure that we encourage all developers of products to push out these updates, these security fixes, and improvements to their device. And we're working on the same balance to figure out exactly how to weigh forcing updates versus just encouraging them.
I think the preference is to try to make sure that auto updates happen seamlessly in the background to some extent, but in certain places that can be disruptive to the user experience, and so we want to be conscientious of that and make sure that that doesn't happen. We've got a question right over here. Sure. So just to clarify, the question was around, let's say you're a manufacturer overseas who's building a particular device type. Your government and Google have a falling out and agree to go separate ways. Can you explain to me in a little bit more detail what that would entail? I see. So the question is around, would Google cut off access for OEMs within a particular country? What happens if that happens? What recourses does the manufacturer have? These kinds of things. So I think this starts to stray into some of the legal territory, and that depends on the context of what exactly happens there. I can say at the moment there's no restriction on these services outside of embargoed countries that US law dictates Google can't act within. So I would be surprised if that were to happen, but it would depend on the particularities of the circumstances. Okay. We have a question here in the back.
Yeah, to beat a dead horse, regarding caching device information in the cloud, some industries, due to compliance, can't use, well, they have to use their own cloud or their own private cloud or their own old-fashioned LAN. Mm-hmm. What's the situation there? And then secondly, somewhat related to that, but more on an OEM basis, like compliance with things like FIPS 140, certain security protocols. That's the only way certain vendors can sell to, say, certain federal government institutions and whatnot. What's the status there? And related to that, code signing, how do you make sure that the signing is the integrity of that?
Okay. So the first part of the question is around different markets and particular device types have certain requirements from a regulatory standpoint or from a certification standpoint in terms of security certifications or potentially HIPAA compliance or these kinds of things as to where they can store data. The second part of the question is around code signing for, I think you're mainly talking about firmware updates and things like this, is that right?
Yes, and maintaining the integrity of it.
Right. So just to talk to the former a little bit, naturally there are some areas that Weave isn't suitable for at the moment, and that includes some things like healthcare devices that deal with HIPAA compliant data. It's going to be a device by device type kind of conversation there. Over time, Google has incorporated a variety of different of certifications into its cloud infrastructure for particular cases, but it's a little bit nebulous to try to talk to that right now. If you have a particular device type in mind and a particular set of regulations in mind, I'd be interested in talking after. Go ahead.
I think we're just about out of time, so I might just answer this and then move on to the next talk. But so was there any part of the question that I missed?
So specifically, signing firmware updates and software to make sure that can't be interfered with en route and that it's what was meant for that device.
So we do take measures to make sure that the thing that is going on the device is the same thing that you pushed out. So I think that maybe the best advice is we have a security talk later today. And so going to that, I think should answer your questions, or if it doesn't, maybe ask this question again, and Paul will definitely be able to answer it.
Right. The quick answer is there will be signing of updates, and Paul can probably go into a little bit more detail later today. But that's definitely a part of the auto update infrastructure. Cool.
Okay. All right. Well, thank you very much.
Thank you guys for your time.
Hello. I now see there's many more of these toolboxes here. I was just walking down the hall, and I hadn't been giving one of these conference toolboxes. I was like, are people bringing cats to this conference? Anyway, hi, I'm Lawrence. I'm a product manager for both Brillo and Weave, and I'm going to talk a bit about Google services for building devices at scale. If you were here the last session, you would have heard Andrew talk about Weave, one of these services, and our communication protocol for devices, and Sam, who talked about Brillo, the OS based on Android. So this session, I'm going to go a bit more in depth about these Google services and our philosophy behind it. So these Google services have three goals. First of all, to help you build a better device experience for your end user. Weave is a good example, as it is primarily end user facing. I'll give an example in a second. Second, help you get to market faster. A lot of these services provide core functionality for your devices that everybody will need, like metrics, like crash reporting. So instead of you having to build these things yourself, we just include it in the platform so that you have it right out of the box. And third, help you operate at scale. The over-the-air update service is a good example of that, as it is very different if you're a hobbyist and have only a couple of devices versus having millions of devices out there and having to update them in the field. So for one, a device experience for the user. You may have, if you were here at the previous session, you may have seen this. This is the setup flow for Weave. A common problem that we heard from developers for devices right now is, well, you ship a device to your customer unboxes the device, plugs it in, but then has to go to the App Store for his or her mobile phone to find your app. And let's imagine we're building a camera, right? So I go to the app and to the App Store and I search for a camera app. Some of your customers will find the wrong app and you will drop them there. So this is why we included with Weave a device setup flow where the moment the user plugs in the device, for Android phones, the user says, okay, Google, set up my device. A device will show up and the flow will guide them through getting the Wi-Fi credentials, assigning an owner, and then right there installing the right app that you, as a developer, told Weave to install. So for the rest of the talk, I shall be talking about services that are not necessarily user-facing, but for you as a developer, starting with how do I configure these Google services? So let's stick with Weave for a second. Or let's talk first about the process. So you're developing your device, and at first you want to find the services that you want and integrate them to devices. Then you launch, these devices become actives, and the services help you iterate at scale. First, monitor to understand what's going on. Second, improve. If you find issues, to debug them, find where they are, and so you can fix them. And thirdly, to update your fleet. Now, the tool that we're using for this is the Brillo and Weave Developer Console. This helps you find those services and integrate them. This is the tool. You can find a tool at weave.google.com/console if you're part of the developer program. So how does this work? Configuring the Weave service. If you go to the Configure tab on the developer console, you'll see the Weave configuration, and this will work similarly for many services. So the first thing that we'll do is we'll ask you, hey, what sort of device are you developing? In this case, in this example, we're developing a camera. So once you've told us, hey, I'm developing a camera, we'll give you the configuration and give you an option to download the templates given that we know what type of device you have. Second, we help you find additional documentation and testing tools. And thirdly, generate the API keys and OAuth tokens for the servers that lives on the device to communicate with our server. Now, a little bit more information about the tools that we provide. So, if you're using the Weave service, one of the tools is testing with prototype devices. again, in the Weave Developer Console, in a tab called Your Devices, the moment you plug in a device that has the Weave service enabled, the device will show up, and it allows you to see its current state, and allows you to send commands to it. So if you have a camera, and you've just implemented, let's say, turn on the flashlight function, you can send that command to the device and debug and test whether it actually works. Then let me talk a bit about other services besides Weave. First, metrics from field devices. So if you're using Weave out of the box, there's a lot of out-of-the-box metrics that we give you. So for devices, they retain an active connection to the Weave server, providing it with state updates and receiving commands from client app. And over this service data, we collect aggregated steps. So we can show you graphs for online devices, as you see here, top versions, top device models, new registrations, the number of commands sent per hour. So if you see those tank, you know there's something wrong with your device, and the command distribution, which gives you an idea of how are my devices being used, what sort of commands are being sent, and in what proportion. So of course, over these metrics, consumer privacy is very important. So we never track a single device, always an aggregation. And for launch devices, there's a 50 device minimum that we track. Then the second service, OTA updates. So OTA updates is one of the most important services that we offer, and you may have heard other people talk about it, and it's for two reasons. One, we would love for device makers to continuously update your devices, both for fixes and for new functionality. And the second is security. Like, if you will want your devices to have the latest security features from Brillo, and perhaps more importantly, if you do discover that there's an issue with your device, you want to be able to send an update to your devices immediately. So this is one of the challenges I think we face as an industry as a whole. And if you read outside articles from the press about IoT, one of the things that always comes up is security. So Paul Covell is another product manager on Brillo. We'll have a talk tomorrow specifically about security. Right now, I'm going to talk a little bit more in depth about what is the OTA update, how does it work. For now, it's Brillo specific, so you have to build your device on Brillo in order to get our OTA update service. So how does it work? To push an update to your devices securely in 5 steps. First, you use the Brillo tools to create a production build and sign it. We have tools that allow you to generate a key and then sign your image using that key. The second step that you do, you go to the Brillo Weave Developer Console and you upload this binary. What we do then, once we receive this binary, is we look, what are the other versions out there? For the most common versions out there, we generate delta so that your devices don't have to download the entire payload every time, but instead can download just the things, just the deltas that is needed for this update. We generate the payloads that your devices will be downloading and sign it using a server-side key. This is to verify that for the device that this download, this payload indeed came from the Google update servers and not some malicious other service. So once you've uploaded your binary and the payloads are there, you select a release channel. So the release channel for Brillo and Weave works just like it works on Chrome if you've ever changed the release channel for your browser. Namely, at start we'll have 3. We'll have a stable release channel. This is where most of your users will be on. We have a beta release channel, which is, you could see as a trust or tester channel. And we have a developer release channel, which your team will use. So each device knows what channel it's on, and knows, and in that case, gets a separate build. So once you select your release channel, you schedule your push. You select your version, select the percentage of users that you'll want to receive your build. For instance, especially for the stable release channel, you probably don't want to push out your release to everybody at once, so you select 1% of my stable users. I want to get this build first, and you select your date. Once you press save, step 5 is watching your fleet update itself. So as you can see here, right now we've pushed something to the the dev channel, the development build. We've scheduled it for November 24th at 12 a.m. So the process now is once this date is hit, a device will check in by default every 5 hours, and it will send to the Google Update Server its product ID, what product am I, what version am I on, and what channel am I on. Then the server, if there is a new download, which in this case there is, will give it a download link. The device starts downloading the update, verifies the payload that it indeed came from the Google server. And for Brillo devices, there's two partitions, A partition and B partition. Let's say the device is now running on the A partition, and we'll start applying the update on the B partition in the background while the device is still active. It applies the update, and now it has to decide when to reboot. You may have seen that there's 1% left on older versions, and you may have wondered why that is. So for each sort of product category, there may be a different reboot process. For instance, for Chromebooks, the user gets to decide when to reboot. Even if the update has been applied on the other partition in the background, the user still wants to decide themselves when to reboot. So it could be that some of the devices, even though the update is there, they simply haven't rebooted to the other version yet. Another example is routers. For routers, you do not want to give the user a notification when there's a new update available, but instead, you probably want to have some heuristics between midnight and 5 a.m. If you see very little traffic on a network, that is your moment to reboot. This is important because imagine coming home from a night out, having to go to the restroom, you're at your door, and at that moment, your smart door lock decides that it wants to apply and reboot. That is not the optimal moment. So for you as a developer, we provide you tools to decide the rebooting logic. Crash reporting. So imagine the situation that we just saw. You are pushing an update to 1% of your stable channel. One of the metrics that you want to be watching is crashiness of your device. What is the number of crashes per hour that we're seeing coming from your device? That's the one you're seeing here, the crashiness. Old Brillo devices, by default, come with a crash reporting service made with the open source daemon called BreakPad. These are open source crash reporting tools. So when you upload a new build to our auto-update service, with it is uploaded symbol files, which get sent to our crash server. The moment one of these devices crashes, it will generate a mini-dump, and when it comes back online, it will send the mini-dump to our crash servers. On our crash server, the mini-dump and the symbol files are combined, and a stack trace is generated and included in a report. And that's what you're seeing right here, the number of reports that come in with those stack traces, which will help you triage the problem. Like if you suddenly see a spike in the number of crashes, we'll show you here, what are the top 10 crashes that you received in the last 7 days? Or you can minimize that time window to see, okay, what are the top crashes from this particular version that I just uploaded? And we'll show you, in this case, if you look at the top two, the top crash has 30% of the total crashes. The second cluster of report is 15% of your total crashes. So if you solve those two issues, you've already solved 45% of your total crashes. And the final column is, what is the delta with the previous time period? So with this, you can decide, okay, these are my top issues, and then dive into an individual report within one of these clusters showing you the stack trace and some metadata of what was going on that device at the moment of crash. The final service I want to talk about that is included with Brillo and Weave are performance graphs. These come from a metric reporting service that periodically gathers data from the device. For instance, in this case, it is what is the data partition usage in megabytes. Other examples are CPU usage, memory usage, or page faults. Because this is data generated from the device, like crash reports, privacy is important. No PII is collected from in these histograms, and an opt-in is required from the end user during device setup before this metric service becomes active. This is useful. You can track over time and over versions, like what is my data partition usage, and does my CPU usage go up over time? And if a lot of users complain, hey, my device is starting to act slow, you can use this to figure out, hey, what causes these field devices to act slow? Over the course of this year, we will start adding more services to Brillo and Weave devices. We'd like to get your input as well. What sort of itches do you have that you like scratched? And what sort of functionality would you like to see in the Brillo and Weave platform that we could help provide for you? So tomorrow, there will be office hours from 12 p.m. to 2 p.m. So come ask your questions there. There's code labs going on enabling Google services and pushing OTA updates if you want to get your hands dirty and play around with this. I'm Lawrence Veenstra. I'm a product manager, and I hope to see you there. Thank you. Any questions for Google services for devices at scale? There's 2 microphones to the side, and there's 1 microphone up there. If anybody has a question they'd like to ask.
I have a question. For OTA updates, do you have to allocate a double the size of memory for the original code and then the updated code? So and then you could swap one for the other when you've finished the update?
Could we put the volume up a little? I have trouble hearing the question.
I was asking, oh, that's louder. Do you need twice as much code space for OTA updates in order to hold both the original code and the updated code?
No, it will update on the fly. So you do need twice as much space because you have 2 partitions, right? Brillo is 2 partitions by default, but it will update on the fly. So update smart about that.
Okay, thanks.
Hi. Yes, up there.
If the customer decides not to register with Google, the Brillo device, can the customer still receive updates?
That's a great question. Yes, it can. The update service is separate from Weave, as in it would require an active internet connection, of course, but the update server still pings in, even if the customer decides not to register the device with Weave. Basically, the fact that it is Google in the background is opaque to the end user, and the end user shouldn't care.
Okay.
All right. Oh, there's one question there. Hi.
Hi. I would like to know how does it compare with platforms like OpenHub that tries to integrate all the smart home automation systems, like for example, SmartThings Hub and Philips Hue or Insteon.
Yeah.
So, do you have something like that for integrating all these smart home systems?
That'll be a great question for Andrew.
Yeah.
Who's the PM for Weave. So if you come to our office hours tomorrow, you could ask him that question.
Yeah, the reason I asked was you were talking about number of crashes. I was thinking if you could have something like that in your system that supports them, we could say, okay, this smart things is better than, for example, Insteon smart.
Right, so you can use sort of a peer comparison, like how crashy is this? Yeah. So for our crash servers, of course, you can only see the crash reports for your specific device. By default, we don't give you access to other devices. It's an interesting idea, though, to do a bit of a peer comparison of all the cameras, which camera is the most crashy. But yeah, for now, no.
All right, thank you.
All right, thanks for listening, everybody.
All right. Hello, everybody. Hi. All right. That's a lively crowd today, so let's make sure my clicker works. Perfect. So hello again. My name is Eitan Marder-Epstein, and I lead the developer engineering and relations team for Project Tango. And today, I'd like to share a bit about our project, as well as where we're going for the future. But before I do that, I normally start off the presentation just by show of hands. How many of you have heard of Project Tango before? Whoa, this is probably the best response that I've gotten to that. I would say 3/4 of you raised your hand. So for those of you who don't know what Project Tango is, hopefully this will serve as a nice overview. And for those of you who do know about the project, hopefully it shows kind of the progress we've made as well as where we're going for the future. All right, so at a fundamental level, Project Tango stems from the observation that today, interactions with our phones really end at the square box of the screen. And whether you're at home browsing the internet for a new appliance for your kitchen, or at work planning for a project that you're going to build, or out at dinner socializing with your friends at a table, your phone is with you, but it really lacks an understanding of your environment. You're limited by the boundaries of the screen. And what Project Tango hopes to do is to break this boundary and to bring your phone and the world more in tune with each other. So we want to teach phones to see and understand their environments. And we would like to augment and improve our own ability to answer questions about the world around us. Those questions might be things like, how much paint do I need for a wall in my room if I'm going to be repainting my house? Or will the couch I'm going to buy online actually fit in my room? I recently bought a sleeper sofa and made a big mistake. Or how do I get from where I am to the laundry detergent in a store? So Project Tango allows us to answer these questions and more, and we use special cameras and inertial sensors that we've built into phones to make sense of the world much like we do. And we allow the phone to build a human-scale understanding of space and motion. And then we expose this understanding to application developers
by adding 3 core technologies to mobile devices. And I'll talk about each of them a little bit here. So the first one is motion tracking, the second is area learning, and the third is depth perception. Motion tracking allows Tango devices to track their position and orientation in space. As the phone is moved through the environment, it keeps a log of its trajectory to within centimeters. This works almost like a mouse, but in full 6 degrees of freedom. Area learning allows Project Tango devices to recognize where they've been before. When a distinctive visual landmark, like a sign or a poster or a picture, is seen, the device stores this in its memory. And the next time it or any other Project Tango device sees this visual fingerprint of sorts, the device recognizes its precise location in the world. So I could walk into a store and recognize that I'm at the checkout register just by seeing a sign above the cashier. And the third technology that we expose is depth perception. And this allows Project Tango devices to see the world in 3 dimensions. And we've done this by adding additional sensors, special depth cameras, to mobile phones. This allows your phone to understand the full geometric structure and also the scale, the metric scale of your environment. So to give a more concrete idea about what this technology enables, it's nice to talk about it, but what I'm going to do is show a video giving an overview of the technology that we've built, and then I'm also going to show a couple of live demos on stage, just to give you a feel for what this enables. So I'll play the video now, and then do demos right after that. Okay. So, as you saw, I think that's some pretty powerful and cool stuff. But there's still nothing like seeing it in action. We don't have a ton of time today, but I'd like to run through at least a couple of demos to give you a better sense of the types of applications that we're building on top of this technology. I will also be available after this session at office hours. And just a little plug, if you come, I'll let you play with the device yourself so you can handle it. So to start off with, I always like to give insight. Can we switch to the device, by the way? Whoever. Oh, awesome. All right, so to start off with, I always like to give a little bit of insight into what is actually going on under the hood. So here you see an image from a wide-angle camera that is mounted on the back of the device. And you'll see a bunch of colored dots in the world, as well as some plots on the screen. And the colored dots are visual features that we're tracking across frames. So we're looking for points that are on corners or anywhere where there's a change in contrast. And we're actually tracking that in our video feed and fusing the data together with information from the accelerometers and gyroscopes on the device, so the inertial sensors. And here, as I rotate, you're probably used to seeing that even just from a gyroscope, but I can actually start walking around the space, assuming my cable doesn't let me down. And I can return, to roughly where I was before. So the device understands how I've moved through the environment. Now, we've also got a depth sensor on the device, which allows us to see the world in 3D. So when we combine the ability to track the device's position as you move through space with the ability of it to see in 3 dimensions, this stage is mostly green, but we'll try and build a little bit of a model. Maybe I can get some of you all in the front. So as I move around the world, you can see that very quickly I'm able to gain a pretty nice geometric understanding of my environment. And this is powerful. This ties your device to the physical world. And when you have this relationship, you can start building applications that before were not possible. So one example of an application is, say I want to take a basic measurement on this wall. So I can measure, that's 0.8 meters. But you're noticing that it's not just a single frame. I can walk around the environment, I can walk up to the front of the stage, and I can produce measurements that are tied to the space that I'm in through the frame of the device moving around. Other things that I can do, say I was interested in hanging a picture here, and I wanted to know roughly the size of the wall. I can also measure area. So you can do things very, very quickly that would take time otherwise. I can also do things like measure through walls. If I wanted to drill through a wall, you can place a point, walk through to the other room, and place another point. I almost want to go backstage to do it, but I feel like that might be a bad idea. So this is really powerful. You're augmenting your world, and you're answering questions that we as humans have trouble with through the device. Other applications that you can use leveraging this same technology involve being able to shop for furniture or for other household items online in a much more practical way. So I referenced before that I really screwed up my sofa, but now I can drag items into the world. I can look at them from different perspectives. I can get right up close. If I want to, I can change the color. And the beauty of this is that this chair is at scale. So if it fits in my room, I know that I'm okay. I can also drag another chair here and align it. I think it should snap. Well, all right. Having trouble snapping. But I can place furniture in my space very, very easily and see how it actually looks. And this application was a partnership, actually, with Elemental Studio, who did the application design, and Lowe's, who now advertises that if you need a new fridge, you can check it out in this application. All right, so that's a practical use of the technology, but we also believe that this technology has the power to unlock our imaginations and to allow us to have a little bit of fun. So this stage was made for this demo, I swear. It's just, so this is Mittens. He's a cat, but virtual. And you can see that I can go up to him and he knows where I am and he'll paw the device. But then other things that Mittens can do, he'll follow me kind of around the world, is that Mittens understands the geometry of the environment. So he can actually jump onto this surface because we have an underlying model of what the surface looks like. And when you take augmented reality and mix it with the ability to understand the geometry of the world, it becomes much, much more powerful. So you can change Mittens to Rufus, or to Gray the cat, who has really big eyes. And they can follow you, around the space, and they'll walk with you as you move. And then the last kind of fun application that I'll show, it's another game that I will challenge folks to beat me at during office hours, is Shell Games at one of our workshops decided that Jenga was a really, really annoying game to play normally, I guess. You have to stack the blocks, they fall down, you have to restack them. It's not so much fun. So they made virtual Jenga. You can see that it's sort of on this surface, and I can take a block and I can move it to the top and stack it. And it's supposed to be a two-player game, but I guess I'm gonna win no matter what. And you can see that it's a very natural interaction where you're using the device as a 6-degree of freedom controller interacting with a virtual object tied to the real space. And then this is not going to go well. Okay, so I lost Jenga to myself, but now I don't have to clean up. So if I wanted to, I could just restart the application, hold tight for a second, and have my tower rebuilt in front of me. All right, so can we switch back to the main screen? So those are all of the demos that I have for you today. But I hope, clicker, oh, this went backwards. Seconds. Okay. Those are all the demos that I'm going to show for you today. But I hope it gave an idea of the kinds of applications that can be built on top of this technology and the power of it. All of the demos that I showed are currently running on our development kit hardware, but this has actually been a progression for us. So it's taken many iterations of hardware and software to get to a platform stable enough to build these apps and to have them work reliably. And we are starting now to partner with OEMs and chipset manufacturers to bring this technology to the masses. This is no longer us playing around. And in fact, at CES last week, we announced the world's first Project Tango smartphone. So Google, in collaboration with Lenovo, is going to build a smartphone that will launch in the summer of 2016. It'll have mainstream price points under $500, and it will launch globally, including in the US. And we know that with a launch of this size and scale, just putting the device out there isn't enough. We really need to have applications and compelling use cases to make this product a success. And to build them, we're looking for help. So we're looking to partner with developers in the space. And to this end, we've launched what we're calling the App Incubator Program for Project Tango. This is, again, a collaboration between Google and Lenovo. And through this program, we're looking for developers and studios who are passionate about the technology, who are passionate about the space, and who have ideas about what they could build on top of this platform. And then Google and Lenovo will work with these companies to provide funding, to provide support, and to help make your vision and your dream of what you could do with an application and platform like this a reality. There will be opportunities to be featured on the device as it launches, and Lenovo has also stated a desire to have some of these apps be pre-installed on the device, opening up the market that will be exposed to your technology. And we are accepting proposals for applications through February 15th of 2016. So we're looking to make decisions as to what applications we fund in the relatively near future. You can go to google.com/Project Tango and you'll find more information on applying for the program. So if you have an idea that you're passionate about for this platform, we really, really want to hear from you. We know that this can't happen without creative input, and we know that we don't have all of the great ideas that could be built on top of this platform. I'll conclude by just saying that we have APIs for C, for Java, and we have a tight integration with Unity. And we are also working on an integration with Unreal as well. So if you use any of those programming platforms for Android, Tango should be relatively easy to pick up. I want to leave some time for questions, so I'll take those now. I think I've been told there are mics up front and one in the top, so I'll take questions. Yes? So the question was, how accurate is the IR sensor? So you don't get direct access to the infrared camera with Tango. I can talk about the accuracy of depth, but as far as seeing through walls, that's something that's a little bit hard to do. But the depth is accurate to about 3% over the distance that you measure. Does that make sense? Okay. Yes? Yeah, so the question was, how does Tango deal with wacky lighting or crazy shadows or changes in the environment? I think you saw in the video Tango working in the presence of a lot of people that were all moving around. And the device has the capability to recognize what are sort of dynamic obstacles in the scene versus static. And as long as it can see some points that it can track over time, it's able to keep its position. Yeah, so if you move in front of the Tango device, you'll actually see the points on you in that display I showed, they'll turn red. And what that means is, hey, like that is not a thing that I should be basing. Yes, yeah. And then for lighting, the camera changes its exposure based on the lighting to try and maximize the ability to track. And that's the other reason we have that wide angle camera, right? We want to see as much of the world as possible. Because if you take a narrow angle camera and you walk really close to that wall, you'll just see white. But the wide angle gives us a very wide field of view of the world and helps the robustness of our system. You, in the, yes, jacket, yeah, you'd put your hand down. Yeah. So the question was, we assume that all the processing is happening on the device, which is correct. All of the processing is happening on the device. And how easy is it to develop a simple app? So there, getting up and running with Tango is very, very easy. In Unity, it takes less than 10 minutes to have a basic motion controlled camera in a virtual scene. In C and Java, maybe up that to 30 minutes to an hour just to get everything set up. And developers.google.com/Project Tango has all of the entry points for our tutorials. And I'm also very happy to talk about that at office hours as well. You standing in the back. Yeah.
So does Google or any of its partners have plans for, say, a planetary scale SLAM geospatial database, sort of like an Instagram for Tango?
So the question was, does Google have plans to, I guess, map the world with Tango? So at Google, we're always interested in mapping the world. We do think that this technology has a lot of potential for indoor navigation. So we've started with some trials where you go to a mall and you turn on the device and you can do things like get directed to a store with turn-by-turn directions. I know I could have used this at CES last week, actually. Vegas is not good for indoor navigation. And you can also do things like try and find your friends because you have a shared coordinate frame. So it's an exploration that we're beginning. We do think location-based experiences and navigation experiences are sort of one of the pillars that we'll explore for this technology.
So no Google Maps integration out of the box?
I cannot comment about Google Maps integration. Yeah. Yeah. Yes. So Intel has announced the availability of developer kits that run Project Tango integrated with their RealSense cameras. And I believe they're $399. So you can today go and pre-order an Intel RealSense device that has Project Tango capabilities. And we're working with them as well as our other chipset partners. Other questions? You in the front row in the back.
Yes. Do you see a future with Project Tango and gaming with like Google Cardboard, for example, virtual headset, all that HMD?
Yeah, so I think the question was, do you see a future for Project Tango with gaming? And I think that there is a huge future for Project Tango with gaming. I think there's also a huge future for using Project Tango for any kind of positional tracking. And you can think about extensions to that. We've played around with taking it and putting it in an HMD. There are other problems with that, like screen refresh latency and all of the problems that sort of come along with that. But I do think that people will use the devices in that way, and it's really interesting to me. Yes? The question was, will Project Tango work outdoors? And the answer there is that pieces of the stack will work outdoors. So the motion tracking and area learning capabilities will work outdoors, but depth perception, yeah, trees and leaves are actually great features to track as you move through the world, but the problem is the sun. The sun turns out to be a really, really strong source of infrared light. And so for the depth sensors that are currently on the Tango tablet, they get overpowered by the sun. So you would be able to do outdoor navigation with the Tango device, but having mittens follow you through the trees, unless you were in a shaded area, would be difficult. Well, I think the problem with using specialized lenses to filter out IR, which is something that you can do, is that the device needs to see the IR pattern to be able to do its depth computation. And so if you filter out that IR, the device doesn't see the pattern. There are solutions to this. Yes, it depends on the sensors. The current sensors, no, but over time, we hope to improve the ability of these devices to see outdoors. Other questions? Yes, you next to the blue, yeah. So the question is, can you share the 3D models that you create of an environment? Right now, the constructor application that I showed you will export to OBJ and PLY files, which are just standard mesh assets. You have to give permission to export, like the user has to click a button, but once you have the file, you're free to email it or do whatever. And you could import it into another Project Tango device's memory space and use it if you were so inclined. Yes? So the question was, will Tango technology be extended into other form factors like robotics? I think absolutely yes. Well, I hope so. My background's actually in robotics, so I have a little bit of an interest in this. But we've already had interest from people who are doing quad rotors, anyone who needs a lightweight localization solution on their device. I think there's huge impact potential there. We're really focusing on the smartphone space first to drive down the cost of these sensors and to make the technology more ubiquitous. We believe that that's the best way to get it out into the world, and then things like robotics can piggyback on top of it. All right. I am out of time, but I will have office hours right after this. So thank you very, very much for your time. Enjoy the rest of the conference.
Hi, everyone. Welcome to the fireside chat for Brillo and Weave. So I hope you've had a great day seeing all the talks here at the Ubiquity conference. And so as you can see, we've had a whole bunch of really cool information just come out today about Brillo and Weave and all the exciting possibilities that it has. So my name's Wayne Pekarski, and I'm a developer advocate at Google. And so I work with the product teams to sort of communicate information to developers and also feed information back to the product teams to help make our products better and so forth. So we all work together and we run events like this. And so we hope you found it very useful. And so what we thought we'd do is have a session where we could sit down with some of the important people on the Brillo and Weave team, sort of talk to them about what makes them do the things that they do and what they find interesting and what kind of ideas that they have. So today we have 3 speakers. We've got Ryan Cairns, we've got Paul Westbrook, and we've got Gaurav Shah. And what I'll do is I'll start off by just asking them to sort of say a little bit about what they do at Google and what their important role is.
Sure. My name's Ryan. I'm an engineering director. I run the Brillo and Weave project. I started the project about 3 years ago, and I take care of all the engineering stuff.
My name is Paul Westbrook. I'm the engineering lead of Weave. We're focusing on the mobile device side and server side of Weave.
Hi, I'm Gaurav. I'm the engineering lead for Brillo.
Cool, thanks. Okay, so I guess I was hoping with the fireside chat we'd have an actual fireplace here, but we don't have that. They wouldn't let us run a fireplace screen on there. So anyway, so today we had the little pet feeder during the keynote. So that's something where I was like, you know what, I really want this pet feeder because it solves a problem that I have. And so I thought it'd be a really cool question to sort of ask, what magic device have you always wanted that now that we have Brillo and Weave, you maybe could build or someone else could build and sell it as a product or whatever? Like, what's something that's exciting? Gaurav, you want to?
So I guess my kind of dream project is really all the walls are screens, and it's easy for me to project anything on any of the screens, or rather the walls. So that's what I would like to be able to prototype.
Well, I guess some of these little boards we're giving, they have like little HDMI ports on them, so you could do something like that pretty easily.
Absolutely, and you can also drive LEDs and LCD screens via the SPI and I2C. So
yeah, actually, one of my colleagues had this cool project where they were controlling strips of lights and they were blinking all kinds of things, and there's all kinds of cool possibilities of little things you can do that doesn't require a massive screen, but you can use really cheap little components to sort of make something interesting.
Yeah, definitely. You can daisy chain them, and pretty exciting.
What about you, Paul?
One of the things that actually I want to build is something to control my garage door, because oftentimes I'm always worried about leaving it open.
Well, then you just drive your car around and come back home and check it again and then drive off, right?
But then you're wasting gas. But the other thing is making sure the lights turn on and off, like especially when detect presence.
What's the thing? I've always wanted something where it's like, what's the state of all the doors? Show me every time they opened, show me a log or something interesting like that, because the door may have been opened unexpectedly or something like that. And yeah, that's interesting. What about you?
For me, it was really, I was working on Chromebooks at the time, and we were doing a bunch of Wi-Fi stuff, and I really wanted a Wi-Fi router that was easy to use, so I sort of kicked that product off. And then beyond products, one of the reasons that we did Brillo and Weave in the first place was we just saw people wrestling with the same set of problems over and over again. Like Google was getting into doing hardware. Everybody was fighting to figure out, like, okay, what Wi-Fi solution do I need to use? What Bluetooth solution do I need to use? How's auto update going to work? What's my security story? And we'd already solved a bunch of that stuff, so we were looking at, like, how do we package that up for people? So that was really my goal with this.
Yeah. I guess security is an interesting thing, because I always have this terrifying thought of, well, if my heater is controlled by my computer and someone hacks into it, they could set my house on fire or something like that. So security seems like a really big deal that you really have to get this right. And so, what kind of things are we doing to make sure that security, because it seems like that's like the #1 priority for a lot of things nowadays. So what are we doing to sort of make it really awesome?
There's a few things. At a high level, we're working on some platform security features in the OS, and we'll let Gaurav talk about that in a second. We're enabling software updates because we don't think that you can have a security solution with devices being fixed in the field. You always need to be able to push new code to them. And then on the Weave side, I'll let Paul talk to what we're doing about local authentication and things like that.
I can speak to the Brillo side. So interestingly, before I was working on Brillo, I was working on Chromebook security. And we ended up designing a very defense in-depth model for building a very secure device. And that's pretty much been verified time and time again based on like various security competitions and intrusion detection, the performance of Chromebooks at these kind of events. For Brillo, I think there are a couple of things that are inbuilt on the platform. So verified boot, which makes sure that you're not running malicious code on your device. I think that's kind of a core part of the security, and we talk about verified boot like starting from when your device boots up. So all the code that runs is verified. Then the other thing that we want to enable is we want to enable like sandboxing and other mechanisms that are default on and that are very easy to use. So we have kind of built a lot of the same technologies that Android already has, plus some of the things that we designed for Chromebooks, like SecComp BPF and other sandboxing mechanisms. So these are kind of a core part of Brillo. And I guess the final part that Ryan alluded to is updates. We really feel that updates are really a core part of building a secure device. Because anything you build, any software you write, it's always going to have bugs. And being able to update these devices in the field and doing so in a way that is very seamless, not disruptive, is error-free is very important. And so update is a core part of Brillo security as well.
I guess one other thing is that like a lot of OEMs, they'll make a device and then they just forget about it. Whereas at least Google sort of does some of the work of doing the security patches, and you can just pull down updates and sort of build it out without having to have your own team maintaining all these. You don't have to worry so much about security.
Yeah, I think a large part of why we don't see a lot of updates happening in the field is there is kind of obviously the device side, the device software, but there's also infrastructure for running updates, for actually serving the updates, for managing updates. And with Brillo, we are kind of making that something that is the same infrastructure that we use on Google for Chromebooks and other devices, and we are making that available for developers to use for their devices. So we really feel like that really makes updates a no-brainer if you're building a connected device using Brillo and Weave.
I was thinking I got to focus on feeding dogs. I don't want to worry about all that stuff.
And just to add to the update story, I mean, one of the big things is like when people are shipping devices that don't update themselves, the whole internet's moving forward all the time, right? People are building new code. So those devices are just going to break over time. They're going to bit rot. The user is going to buy an experience today, and in a year that experience is going to be broken. And what we really want to enable is an always up-to-date, always working experience for devices that get better as opposed to degrade over time.
Yeah. You were going to say something, Paul?
Yeah, so I was talking about the Weave side.
Sure.
So on the Weave side, one of the benefits of it is actually dealing with the Google Cloud. So the devices themselves actually have a secure connection to the Google Cloud, so they can ensure that the commands that are received by the device are actually authenticated to come from Google. And then also the other part is actually the authentication, or the sharing model. So a user has ultimate control over which user as well as which applications have access to their device. And so then they can both grant access as well as be able to revoke it in case there's a bad actor or some behavior that's actually not expected.
What's the thing? I mean, there's the possibility of bad actors at so many places in the chain that it's very important that you secure everything. You can't just get away with having some parts secure and some parts not.
We agree, and in addition to like the cloud connection, Weave also has local authentication. So when commands, like for example, let's say the internet connection goes down, so commands that go between a phone to a device, we can still ensure that those that communication is secure as well.
Mm-hmm. Oh, cool. So one question I hear people ask me every so often is, so we've got Weave, and then we have Nest, which they have their own IoT story as well. So how does the whole Weave story fit in with what Nest is doing right now?
They're different product experiences for the consumer. From a technical perspective, we're very compatible. In fact, we're trying to offer Thread and Weave on top of Brillo so that people who want to build works with Nest devices with Brillo are able to do that. So with Thread, you've got layer 2, layer 3. With Weave, you've got a high-level protocol. And with our Weave, really the idea was to tie in the mobile experience with the device, right? So we wanted to focus on gateway protocols instead of focusing on more edge-oriented protocols, so that we could leverage the technologies that are in the phone. So primarily Wi-Fi and Bluetooth.
Yeah, okay. Anything else?
In addition, as some of the previous talks mentioned about the schemas, and so we've been actually working with Nest to on the device model schemas. So there's a consistent model for actually representing devices across both platforms.
Okay, cool. And so another question people commonly ask me, which I thought I'd bring up here as well, is that there's lots of IoT devices and microcontrollers and kits and different ways of building little apps that flash lights and things like that. So how does Brillo sort of differentiate itself from there? It seems like the market is quite saturated with different projects and companies. So what are your guys' thoughts on that?
Yeah, so the thing that we found with a lot of these other platforms is that they're really great experiences for trying something out, prototyping, having some fun on a weekend. But when you go to commercialize a device or take it to manufacturing, there's a lot of challenges, right? Then it's not easy to do out of the box. And what we have is a system that you can take all the way from the prototyping stage, where we've got a bunch of dev boards that you can buy. When you've got new silicon, it's very easy to move your project to a new board without much code change, and take that all the way through the manufacturing process. And I think that's a key differentiator.
So how does that work? So, so the manufacturers have some ability to customize them, or?
No, it's more about being able to work with the silicon vendors and tap into the hardware ecosystem so that you can have a common bit of code, and then go to a Qualcomm or a Marvell or a MediaTek or an Intel and get a BSP from them.
Yep. All right, so they provide the support package for their particular processors, whatever. So then you can make your own board and then drop their processor on, and they've ported the kernel over and the drivers and all that kind of stuff.
Exactly. So you're not tied into the platform that you ended up prototyping with. You can go and talk to anybody, whether it's Imagination or Intel or.
Okay, cool. And so, yes, I mean, right now, I guess everyone got their little kits to work with. So some people got Dragon boards, some people got Edisons. I mean, the cool thing about them is they're very similar. The build process is the same, and I guess you can see it from the documentation. Is there anything you want to add, on that?
Yeah, I think one of the things that we have noticed on internal hardware projects as well is that oftentimes you kind of start off by prototyping on one board or kind of one set of SoC, and then you try to move it to a different one for commercialization or for cost purposes or something else. Like maybe you need a new feature. So with Brillo, we have kind of designed that model to, we designed with that model in mind. So you can actually prototype on something like an Intel device, Edison, and then you can actually move that to ARM. You can also move that to MIPS, so you can get an Imagination board, and you can move the same code with minimal changes. And the way we do that is by kind of making the what we call the BSP, or the board support package for each of these SoCs, very modular. So your code is separate from the BSP, which is the code that enables the SoC, which is very different from the BDK, which is the Brillo development kit. So you can compose these things together, and you can swap out one BSP for a different board's BSP.
Yeah.
And that falls very naturally.
Well, I guess from the code labs, so we have some code labs next door as well, which we're going to have open tomorrow if you want to try them out. And also you have access to them on your own machines. But you get the BDK, you then download the appropriate BSP, but you can very easily just change this config file, which flicks you to a different BSP, and then you type make, and it kind of takes care of it. So I guess as long as you're writing in C code, then if you're not doing any assembler, then in theory it should be pretty portable.
Yeah, exactly.
Yeah.
And over time, as people build these devices, we anticipate that they're not actually going to build one, right? You're going to be successful. You go out this year, you have different silicon than you have in the next spin of the product. And the code maybe is the same. And we want to make sure that your projects can you can have the same project on top of multiple boards that you've shipped, so that you don't end up with, a morass of all this code that you have to maintain for basically different spins of the same project.
Yeah. So I mean, in the past, when someone made a router or a light or something like that, I mean, so they had teams of people who have to hack kernels, and what's the kind of difference from before till now? Like now that we've got Brillo and Weave, this is the workflow. How complicated was it before? Do you want to sort of explain, how much people you needed to have to sort of build a product?
So I think one of the, it's very, the development model was very specific to the board, and it was pretty much throwaway work. So let's say that you're trying to build a router and you started on a particular chipset, you decided to move to a different chipset. It's just going to mean a completely new code drop, and you're going to start from scratch. You're going to rewrite a large number of portions of things because you don't have things like a HAL. So the hardware is not abstracted. So you're really kind of, you're writing embedded software, but you're also writing embedded software that is very much dependent and makes assumptions of the architecture it's running on the specific details of the hardware. And I think one of the things that we're trying to do with Brillo is to make that, to kind of abstract away those interfaces, whether it's things like various hardware peripheral interfaces, or it's like how do you configure your kernel for specific features, or APIs for dealing with sensors, for example. So we're trying to kind of abstract away these details so that when you're writing your code, you don't have to kind of make assumptions about the various hardware implementations.
Yeah, yeah. I mean, it sounds like a nightmare where it's like, a kernel bug comes out. So they might patch in a Linux kernel or something, but then you don't know it's there, or you don't know what version you're on. You might not follow it. So if you forget to pull those patches in, you've got all these vulnerable devices that people don't know about. And it's just, yeah. And if you've got 1 billion devices out there and you need to keep them up to date, if you miss this patch, then it could be catastrophic.
Right, and what we're trying to do is create a center of gravity for all these BSPs upstream in our repository, so that when these bugs get found by the vendor or by us, they could get fixed in one place, and then everybody can then pull from them for their own individual products.
Yeah, cool, nice. Okay, so we have the audience here. So we have a microphone floating around somewhere here. So if anyone has any questions, if you'd like to ask of the team, do we have a mic somewhere?
We've got 2 mics in the back on the ends.
Oh yeah, in the corner of the room, we have a mic there and a mic there. So if you had a question, we'll see what we can answer for you.
Excuse me. So if I understand correctly, you want us to make our devices available on Weave or through Weave, but Google itself will not make Nest available through Weave? Because it's special? I don't understand this.
Oh, so it's more about the Nest experience. So what does it mean?
Yeah, we're working with the Nest team to try to make Nest available through Weave as well. The big thing today is that they're different because we're different teams and we're trying to align those things. Like Paul said, we're working on shared schemas so that the developer experience for a Nest device should be different than the developer experience for the same like kind of Weave device.
So it will become available through Weave?
We'd like to.
I guess the thing with Weave is that right now we have specs for it. There's all these different device types. I can't remember off the top of my head. Do you remember? Like it's like light bulb and.
So I mean, I can briefly talk about the schemas. So we actually have some device guides that actually talk about light bulbs and air conditioners and a number of other things. But the one thing about the schemas is actually they're composable. So we actually take the individual traits of, let's say, a light bulb may be dimmable or not, or have color or not, and you should be able to, a hardware maker should be able to take the individual components that they want and actually make the, define the behavior that actually corresponds to their device. So yes, we do have device guides, but we also have, we define the schema as individual traits that.
And we're also trying to work to align the Nest Cloud and the Google Cloud so that developers can work with both.
Mm-hmm. I guess the other cool thing is that with these schemas, if you build a device that implements the light bulb schema, like anyone can write an app that controls light bulbs and anyone can write an app that controls air conditioners, and the app doesn't have to be tied to that device. So it's kind of nice because you could have a house with different light bulbs from different companies and they can all talk together, which is sort of a new thing that I think someone talked about it today earlier during one of the talks, which is, you want to be able to make these things all work together. You come home, your light bulb turns on, your doorbell is synced to it, your music starts playing, things like that. So people have the ability to build these kind of cool combined experiences that has been very difficult to do before.
I mean, personally, I'm very excited about some of the opportunities that app developers have now. I mean, being able to actually combine these capabilities into a single experience.
Mm-hmm. Yeah, so, I mean, do you have any things that you're, like, excited about in particular? Like, I don't know, is there a particular kind of scenario or demo that you want? Because I'm sure someone will have one of these built by the end of the code lab tomorrow.
Okay, so this is what I want. No, I mean, like for example, I think like being able to unlock a door and actually have your lights turn on automatically for you, or based on the time of day, have different behaviors. I mean, I think there's a lot of experiences, especially across different manufacturers, to be able to actually have the consumer not have to worry about buying one particular brand of a product and be able to actually have it work on multiple brands.
Well, the other thing is, I mean, because it's a ubiquitous computing conference and we're talking about many different areas, I mean, so beacons could be combined with this. Like a beacon can announce presence, like, if you could have like a beacon on your keychain, or you could have one in your car or something, and then it's possible for your phone to detect, okay, I noticed you've just gotten out of your car, but now you're approaching your house, or Wayne has come home, or Paul has come home, or whatever, and you can detect different things, and you have different theme music on. So when I walk in, I can have, my theme music. Actually, I remember I went to a conference once, and this guy was talking about this concept of playing theme music whenever you came home. This was like a long time ago.
What would your theme music be?
Wait a minute, I'm asking the questions here. What's your theme music?
I have no theme music.
But I think that, I mean, especially for, I could imagine like using the beacons to actually detect presence in the room and actually turn on and off lights, actually control the air conditioner or fans. I mean, there's a lot of opportunity, especially being able to talk to devices as well as detect.
Well, what I want to do actually is I want to put a beacon on my dog's collar, and then I have a sensor on my couch that detects when they get on the couch, and then it sets off an alarm or something like that. Because I actually have a legitimate problem with this. It's a lot of my ideas that I build are actually problems I'm trying to solve for myself, but I turn them into work problems so then I can write blog posts about it and stuff like that. But my current challenge is a couch detector or something to keep them off, because it's actually really hard. And I would love to buy something like this, and like a trash can that detects when it's been popped open incorrectly, when the dog sticks its head in there to pull food out, all kinds of, the internet of dog products, it's exciting stuff.
Yeah, I was going to add, the big thing to me is that we don't make end users programmers, right? Like I want to buy all these products, I want to bring them into my house, I want to do different things with them, but I want this experiences to be suggestive. I don't want to have to think about like, okay, how am I going to combine these things?
Yeah, I think a lot of people don't know. They want to have a good time, but they don't know how to code. And you don't want to have a, if this then else type scenario. And I guess that's where Nest has been successful with its thermostat, and that it just does the right thing, and you play with the thermostat, but it's not a traditional set the number type thing. It tries to look at your patterns, and I guess now people have the opportunity to build exciting things like this, but that's the challenge now and so we've had a bunch of talks about machine learning and TensorFlow and all these other things today. So I guess the thing with ubiquitous computing is we're combining all these different areas together. So you've got your air conditioner, you've got your car, but you can use machine learning algorithms to sort of study patterns and try to do the right thing for the user when they want it. And we have a question in the back there, yeah.
Hi there. I hear a lot of you talking about both Brillo and Weave on setting state, on, this will turn a light on. I will know when a light is turned on. I'll have all of these things. What I'm not hearing are the inputs for some of them. So I'm not hearing, for example, how to use Weave to create the light switch, just the switch part. I kind of have an idea on how Weave would do that on sending it, but not how that switch would say, okay, this person has now toggled this person is now issuing a toggle command. Or even on the Weave side, how to read for a toggle command. So that's kind of what I want to hear more about at this point.
Yeah, that's a good question, yeah.
Sure, so I can start with the Weave side of this. So as part of the schemas, like for example, let's take a light switch, for example. The schema for a device actually represents a couple of different things. One is the commands that it can handle, and the second part is actually the state that it actually, that it's currently in now. And so, for example, an application or a service can actually watch the state and actually watch state transitions and potentially use that as a trigger to perform some action, whether that action happens to be another command or happens to be, I don't know, whatever it wants to be. The other part is actually the commands. And so, for example, if I, in order to issue a command to a device, there's some schema, and so applications would have to actually do that. So in the case that you gave, like for example, a light switch, I would imagine, like this is just off the top of my head, I would imagine a light switch would actually define a state which is on or off. Maybe it's brightness if it's a fancy light switch. But it would also represent a command, and so I would be able to issue that command to that light switch to actually trigger that. That command would actually affect the state. So then an application, in addition to actually controlling the voltage or the of whatever was connected to that thing, it could also, applications could watch that state change.
Well, but the problem is whatever is connected to that thing is another completely separate Brillo device. So really, I now have a virtual switch and a virtual light, and somewhere I need to make the connection that says, when I toggle any of these three switches on different sides of my dining room light needs to turn on. And I can see how each individual part of that works, but I can't see how it comes together.
Okay. Yeah, so the first cut of what we have is very much phone to device, but we're also working on triggers and signals, which we haven't rolled out yet.
Okay.
And that'll let you to do
That's
things
the
like
glue,
the device-to-device stuff what you're talking about. Like I flick this device, now I need to go send a message to these other things to go broadcast what changed, or somebody might have to subscribe to something and say, oh, this state changed, how do I take action on it? We're working on rolling that stuff out. It'll be a little bit, but stay tuned.
I guess the thing also that's important is that the Weave APIs are very cross-platform. Like they work on iOS, Android, web. Have I missed anything? Yeah, they work across most of the major devices, so it's nice because you're not restricted to just forcing it to work on a phone or anything. You could build something that runs on a server in the cloud somewhere or whatever. Yeah. Okay, so while we're talking about light switches and stuff like that, so what kind of markets are you guys excited about for different kind of, what are the big areas you think are going to be huge?
So I guess we're doing a lot of consumer stuff right now. We're talking a lot about home automation. And I think the opportunity here is a lot bigger than just home automation, which I think is a really interesting vertical, but it's, not the whole pie. The thing I've been telling the team is think about how we put a computer in every device and what does that look like. And I think there's a lot of scenarios like smart cities, like with parking meters and things like that. There's a lot of industrial use cases. There's a lot of potentially healthcare use cases. I don't know if we're going to get into that or not, but definitely a lot of potential to put computers in things, and interesting problems fall out. And I think we can.
Yeah, well, that's the thing. I mean, I guess with software, it's like, not everything's about consumer devices. Right. There's a lot of companies that do contracting work who, they're asked to build infrastructure to, put a smart meter in every house to measure its power usage or something, and those kind of things would all be useful for that too, yeah.
Like one example would be cars, right? Like everybody thinks about cars in terms of like, you're going to put a computer in the car, navigation system, infotainment, all that sort of stuff. And that's great. And I think Android Auto is pretty awesome. But there's all of these other subsystems inside of cars too that we don't address. So for instance, like in a Tesla, they have an NVIDIA Tegra processor just running the gauge cluster that's doing some basic graphics for things like, speedometer and user input and things like that. And there's all sorts of other subsystems too.
Yeah. So earlier we talked about displays. So with the little Brillo boards, they have an HDMI output. What kind of hardware do they have for graphics rendering? Like, do they do OpenGL, or I'm not sure actually?
So right now, graphics support is, we can support very basic non-accelerated graphics, but we are working on it, but nothing to announce right now.
The goal is to be headless for the short term.
Yeah. Well, that makes it really low powered, and although those boards are really powerful, they've got they're almost the same chip as in a cell phone, basically.
Right. A lot of that comes from the fact that we were trying to get something to market quickly, and Qualcomm and all of our other partners wanted to put out a very full-featured set of boards so that developers have access to everything. And the goal would be you start with something like that that's geared towards a cell phone and then scale it down.
Yeah, yeah. Okay, cool. Any more questions? One in the back there, yeah.
Yeah, this is going back a little bit, back a question or so. Say my use case is, I just got the word I'm heading into Tier 3 from PG&E. My question is, who's responsible around here? That's a historical question. Now, for where does Weave run when you have a question about a number of devices that are all, secondary devices? They're power users. And I can get how much power they're using, but where do I put it? Do I have to throw it all the way back to the cloud? And does that scale, really? If it's a local resource, where is it a capable device, a capable thermostat that would run on, or some kind of neutral gateway device?
It sounds like there's logging, and where would we put that?
Yeah. This is. I do historical log. I log continuously.
So just to make sure I understand the question correctly. So you would like to create a device that actually track the power usage at your house, or is this you want the power usage of the Weave devices?
Of the lights and the appliances within the house, not.
He wants to find the culprit.
You're aggregating everything.
Yes, yeah, and recording it piecemeal.
Sure. So this is possible to do with Weave. So one thing that you could do is actually create a Weave device that actually aggregates this and actually represents this the power state as state changes. And you could actually if you don't associate that device with the cloud, then that logging would actually remain local, and you can continue that. Or you could actually associate that with a Google account, and then that would actually then propagate to the cloud.
Okay, and this would not be a smartphone platform. This would be a permanently resident device within the home, perhaps DSL modem, an augmented gateway device, Weave capable.
Okay, so there's a hardware device that's in the house that would actually gather this information. So that should be definitely doable with Weave, as well as that could run Brillo as well.
I'd say that things like the data retention policy and how much you upload to the cloud, and how long you keep things uploaded to the cloud, and who's allowed to see it, and things like that, all come down to sort of both OEM preference and probably user preference. And depending on who made the metering, or what the user wants to pay for, or what the economics of the situation are, the device maker, I think, would would come up with a suitable policy there. But we should be able to have a lot of flexibility in the platform to be able to do different things for that.
And devices can be shared too. Like, I guess if you came over to my house, I could say, hey, I'll share this device with you, so you could feed my dog or something like that. So you can give access to other people for a device you have.
That's correct. I mean, and even like sharing devices, not even necessary for functional, but like for viewing access. So for example, in the case of a power meter, let's say, for example, I want to share this device with my wife so she can see how much electricity we're using at home. So that's also possible as well.
Okay, another question over there?
Yeah, I got a couple questions. Just really simple is what Android version is Brillo based on? And then is there any plans to kind of bring that modular update architecture to just standard Android on phones, so I don't have to wait like a year for the Marshmallow update on my phone?
Okay.
So nothing to say about updates on Android, but we can tell you what version.
It is based on the latest AOSP sources. In fact, we do all our development in open source, and we do it like regularly, not just code drops.
Yeah, we work in the open.
In terms of versioning, I think one thing to keep in mind is that we are not using the same version or numbering scheme as...
Yeah, it's not like KitKat, Marshmallow.
Yeah. And that's just because all our development is in AOSP.
Having said that, we don't want to encourage people just to take random snapshots of AOSP and push them to users. We want to have some well-defined releases, but we want to do it at a more granular level than what Android does today with the dessert releases.
Okay, and also my second question is kind of what's in it for Google, or what's your monetization strategy? Is there like some kind of licensing that you're doing for hardware manufacturers, or are the app developers going to have to pay his licensing fees, or what's up with that?
So we're not taking a license fee. When I think about what's in it for Google, especially when people ask me at Google, what's in it for Google? The answer is we have a lot of Android developers, and we have a lot of developers that we want to make sure that they can program against the physical world, and this is one way to do it. We also have a lot of services, and our developers build a lot of services, and we want to create a platform where both our developers and us can easily distribute our software on top of. And I think by doing that, that creates a lot of future monetization opportunities for both Google and our developers.
Well, that's also why we're running this conference, I guess, is it's part of all the different products. They all sort of fit together. You got Brillo and Weave and beacons and wearables and all these different things, and they're all kind of, they each bring a piece of the puzzle that they can't all solve the puzzle by themselves, but combined together, they do very interesting things. And like you said, there's all these Android developers that gives them new capabilities and things like that. So yeah.
Awesome. Well, thank you for that, because the other guys are doing pretty much the exact opposite. So thanks.
Thank you. Question over there?
Yeah, I had two different questions. The first one is, considering the Weave is a crucial part of the infrastructure and communications, what is your target SLA for it? And if there's any sort of queuing in case of an outage or any sort of downtime? So.
I missed the last part of the question, but I had SLA.
Would you mind repeating the question?
Just what would be the SLA of the Weave services as a whole in the cloud API side of it? And is there any sort of roadmaps for queuing or any sort of contingency plans when there is an outage?
So I mean, Google services are the Weave service is running in our backend, and I don't know if we publicly say SLAs.
Yeah, being that this hasn't been fully released to everybody yet, I think we're holding back what our SLAs are. But
yeah, right now it's a developer product, so please do not build a nuclear reactor or anything important with it, because that's not cool. So it is beta software, so please treat it accordingly.
Like any Google product, we're all carrying pagers, and we're all trying to get latency down, and we really care that 90th percentile is really fast and the uptime is really high. Unfortunately, I can't quote you an exact number right now.
Fair enough. Yeah. The second question is, the whole movement of Brillo Weave is about interoperability, ability to connect everything. But the realistic sense is that there are several other IoT-based platforms out there, and for you to expect a consumer to only use Brillo or Weave-connected devices, probably unrealistic. And is there any thoughts? This is not any plans or anything like that. Any thoughts from you guys as far as any future plans or talks or discussions with other major partners or players out there for interoperability between platforms.
So at least from the Brillo and Weave point of view, I mean, we're open. So for example, if an OEM wants to make a Brillo and Weave device, we're not going to prevent them from integrating that device with any other platforms.
Thank you.
That's right. Question over there.
Just curious for your thoughts. Let's say that I'm a device manufacturer and I'm deciding what platform to sort of build my new device off of. I'm kind of curious what your thoughts on the story would be that you would tell. Why would I choose to build on Brillo, say, as to just putting together a set of Yocto patches or some other embedded Linux system? Is it just primarily the Google services, the over-the-air updates, metrics, that sort of thing? Or are there benefits to, say, using the Android stack or other things that you see bringing an advantage to a device manufacturer over something like that?
So I think a few things. I'll take a couple and then maybe Gaurav can chime in. But the one I think of most is the Android hardware ecosystem. It's very easy to go to any silicon vendor who's supporting Android and say, give me a Brillo thing. And the second one is obviously the services that you mentioned. There's a lot of stuff like updates and analytics and things like that that you get from Brillo that you don't get in other stacks. Gaurav, security?
Yeah, I mean, I think security, developer experience, hardware ecosystem, yeah, I think that kind of covers it. And I think we're also very kind of proud of the services with respect to analytics and updates. I really think we have the kind of the best of the breed there.
Okay, thank you.
Over there.
Yeah, I'm pretty sure this is more of like a manufacturing concern, but we talked a lot about security. How about safety? Like, when you're defining the schemas or whatnot, are you concerned like a user or a developer might turn on the thermostat to like 160 degrees rapidly, or even other things like that?
That's kind of hot. So I think there's a couple things. One is we are working with the OEMs and the hardware makers to actually define the schemas. So there's going to be, the schemas also support limits and ranges. And so for example, let's say if all manufacturers agree, I'm just going to pick a thermostat, say that 160 degrees is too hot. There would be some agreement working with all the manufacturers to actually have some fixed limit. But ultimately, I mean, the hardware maker is the one that's responsible for making sure that their hardware actually functions correctly. And so I think that whether it's actually through Weave or someone spinning the dial too far to the right, the device itself should behave correctly.
And I guess that's something else to think about, because when I was building the dog feeder, one of my concerns actually is that if the dog feeder fed continuously that entire tub, it can actually kill a dog. I've actually taken my dog to the ER twice from eating too much. They will eat too much. I couldn't believe it, right? It cost me $500. But anyway, the point is that I was like, well, if the software fails or if a wire shorts out or something, you really have to build multiple layers of protection into the device. So maybe with the switch that runs the paddle feeder, it should say, well, if the switch ticks more than 4 times in a second, you should shut down. And if this happens, you should shut down. If this, like, you got to have all these extra safety features in hardware as close to the metal as possible to shut it down and put it in a fail-safe mode so that it fails gracefully, because putting all the food out is unacceptable. It's like an airplane shutting its engines down if it doesn't know what it's doing. Like, you've got to sort of design the hardware in a way that really tries to think about what's the worst case scenario and what can I do about it. So like if it had a 160 degree thing, you'd have a thermal fuse that melts at 150 to stop it from getting to that point. So I guess have multiple levels of protection and don't just rely on the software somewhere else, because the user, if they set the dial, then it would be kind of crazy to allow them to do that.
Yeah, I mean, we certainly can't design Brillo and Weave to, deal with operator error or, malintent from the hardware or things like that, but.
What's the thing is, like, there might be cases where you want to set a thermostat to 160 because you're building an industrial oven or something, and that's a desirable outcome. And so you got to make sure that, the designer still has to think about these things very carefully. Any more questions? Yeah.
Was that dog that overate different than the one you had on stage today?
A fellow Googler from the San Francisco office had that dog, but my dogs are at home, but it's a different dog. But it's a constant challenge. It's a great motivator for coming up with innovation.
Early adapter dog.
Exactly, yeah.
I got to say, I hope you guys are learning as much about Brillo and Weave as I am about Wayne's dogs.
I got to write a book about him one day. Yeah, question.
So I haven't heard much mention of this in other
All right, so just to repeat the question, I guess for anyone else who has questions, if you could go to the mics, but the question was, what's the pricing model for the cloud services and things like that?
TBD. Right now, there's no charge for, I think, up to 500 developers.
500.
I think for early access, don't quote me on that, it might be 100.
Some of the other cloud services they offer,
Assistance with programming stuff? Like what kind of assistance?
Like you want back-end storage and things like that, and how are we going to price those services? TBD, nothing to talk about today, sorry. Yeah, right now we have crash reports, analytics, storage for updates. I know Lawrence, do you have a number in mind?
Do you want to go to the mic? Go to the microphone? Yeah.
So for things like metrics, the storage requirements are so low that it's likely that they'll remain free. But for updates, for now everything is free. But once we see what the adoption is like, and if people start to store a lot of different updates and doing it every day, then we may have to revisit that. But for now, it's free, and TBD what the pricing model will be.
Actually, I remember when I saw Lawrence's talk earlier, it has all these graphs that you can draw of like temperatures and things like that. And I think it's going to be really cool because you're going to have, some company's going to make a fleet of devices and they're going to be like, wow, we had a huge failure rate and all of them had a little spike in temperature 1 week before they blew up. And so a week before you could go, oop, that device is going to fail. We can send a field technician out. And so there might be a possibility that you'll just get a call saying, hey, your oven's about to fail. We've already scheduled someone to come out between next week and next Christmas to come out and they can fix it up for you or whatever. It'll be a way of preemptively doing maintenance because the worst thing that can happen is it's the middle of Thanksgiving and your oven fails. Whereas I think there's all kinds of exciting possibilities to sort of learn about your device fleet and what's going on, and it helps you with maintenance and doing research into making more reliable products. And
yeah, I mean, it helps with things like phone support too. I mean, if you could give those that data to your phone techs in the future, maybe that's a problem that we could help solve.
So many years ago, I did tech support at an ISP, and doing that was the hardest thing. When you didn't have remote access, you had to coach them through a phone. And it was even better when they couldn't get the phone to their computer, and then you had to talk over.
Well, I mean, not so much remote access. I mean, like if you had people working a call center and you knew that there was a big failure of all your devices in the field, you could tell them like, hey, call volumes are going to go up, and here's what you could tell people.
Yeah.
Even before the remote access stuff.
I think it's going to add a lot of really cool possibilities for that. We just haven't been able to have that kind of thing. Like PCs, they can kind of do remote support, but every other device is kind of like, press the button and bring it in and replace it. And that's quite expensive, I guess. If devices could sort of self-report, that would be really cool. Any more questions?
That's actually a great lead into my question. We heard a lot about rollout support. What about rollback support?
As in backing a firmware update.
As in if you push something out to the field and you start seeing a tremendous number of failures with that, is there a way to say, okay, let's easily go back to the previous version, which may or may not still be installed on the person's device? Because we heard about partitioning also. Is there a way to say, look, that thing that we sent you yesterday, forget it. Just forget it.
So we can always, there's always the option to push back a previous update. When the update is pushed, your user data is on a different partition, so that's not clobbered. So you can actually go back into the same state you were before the botched update. But in general, we have actually kind of designed the update model to make it easy to do rollbacks.
And is that a real rollback, or is that just pushing out a new version that just looks like the old version?
So there are two kinds of rollbacks. So there is a rollback that will happen automatically when the device detects that the new update is bad. And that's basically, it won't finalize the new update, and it will keep the old version around, and it will roll back to it when it detects that condition. And if that usually catches 99.999% of the cases, if done right, and I think we do it quite right. And if that doesn't work, then there is always the option to push the old update payload again, and use that to bring the device back to the original state.
Okay, cool. All right, well, I guess we're almost out of time. So did you guys have any final thoughts? Oh, you got a question there?
It was kind of an extension of the OTAs. Is there going to be like a certain time limit that OTA should complete? Like it shouldn't take half an hour if my door lock can't open for half an hour. So is there going to be like your update should only take 30 seconds or
so updates actually happen in the background. So the device should still function while updating. It's when the device decides to apply the update, which is the question, and that policy would be different depending on the type of device that's there. So the user shouldn't be hung up waiting to interact with the device while it's updating. That would be a pretty bad experience.
Yeah, and the other technology we have is we do delta updates. So the actual size of the update is very small, and so you're not like downloading. Let's say your image size is 100 megs, so you're not downloading 100 megs. You're just downloading the delta, which might be something as small as like 6 megabytes. So that means that the time to download and time to apply is also less.
Cool.
So last question. The main goal of Weaver's interoperability, right?
Yeah, the question was, what is the main goal of Weave interoperability?
I would say that's one goal. The other goal is actually enabling. Security is always a goal, but I think it's enabling application and device developers. So I think that with the Weave APIs in all Android and iOS and web, it's very easy to write a application that talk to multiple devices.
And one thing that we haven't mentioned about Weave is smart setup. One of the big challenges that we see is when users take these devices home, the first step is getting it on your Wi-Fi. The second step might be provisioning an account. And the third step might be downloading the app. And with the smart setup stuff, you can just go and say, okay, Google, set up my device. We scan for the device, you select it. The app for that device automatically downloads in the background, and it connects to your Wi-Fi automatically. So the provisioning of it is very seamless. And what we find for legacy products are things like things that were designed to be used in a dumb way and maybe a smart way, is that potentially still dumb TV remote controls, as well as smart TV remote controls, but yeah. But the idea is that you don't have these misconfigured devices, right? So there's a lot of people who sell Wi-Fi enabled devices where something like 50-60% of the users don't actually connect them to Wi-Fi ever. And one of the goals of Weave is making sure that the complete experience is configured out of the box without much effort.
Yeah, nice. Okay, well, I guess we're kind of out of time, so we've got another session coming up. So we have, at the end of this session, so we have a bunch of demos happening during the cocktail hour. So some Googlers have actually brought in machines and devices that they've built to show off some things that they've done with Brillo and Weave. So we've got that happening. We're all going to be around to ask questions of. And then tomorrow in the Code Lab room, which is sort of outside the building and one building over, we have computers set up where you can try out the Brillo BDK on one of our machines. You can also show up with your own laptop. And we're going to have office hours where various people from the Brillo and Weave teams, all kinds of different people like engineers, program managers, things like that, everyone's going to be there. And you can ask questions, show them code, or we can walk you through the code labs and things like that. And if you've had trouble setting up one of your devices that you've got in your little toolbox, we can help out with things like that. So there's a lot of, please take advantage of the fact that everyone's here tomorrow. And so enjoy that. So that's the end of the session. So thanks very much for coming by, and we hope you all had a good time. Thank you.
Thanks for having me.
Cool.
Hey, everybody. So just before you leave the theater, hi, Wayne. How are you? I just wanted to take a moment to thank you all for an excellent day one at the Ubiquity Dev Summit. Thank you for being here and for making this a really wonderful environment for everybody. I also wanted to remind you that I know you're about to leave and go to the after party. Don't party too late. We have the keynote for day 2 starting here tomorrow morning at 10 a.m. and a whole day full of sessions of great content. And I may have 1 or 2 more things for your toolbox. So we'll see you tomorrow morning.